Welcome, everyone. This is Michael Gibbs, and I'm so excited to be here for our completely free AWS Certified Solutions Architect Associate Bootcamp 2022. And this is an AWS Solution Architect certification course. At some point, you know us, we talk about AWS Certified Solution Architect interview questions. This is a completely free AWS full course tutorial, a free AWS certification training, and it's an AWS certification course online. The reason we do these free AWS courses is to make sure that you all have access to quality training, the kind of training that you would get in a paid boot camp. I know there's a lot of people that can't afford $4,000 to $5,000 that it would be for a free boot camp, so we're doing it completely free for you because it matters to me that everyone, anywhere in the world, has access to quality education so you can build your best technology careers. Now, this is an AWS Cloud Computing full course. It's really cloud architect training, and we'll talk about how we do it very differently than others. Now, I want you all to get the maximum experience of this training. And according to do so, I want to give you some tips along the way. We have AWS labs that we would like you to do that are mentored from my team, and a completely free AWS Certified Solution Architect Associate and Professional book. And we put the free AWS Certified Solution Architect Associate and Professional in the same book for the following reason. We'd rather give you more than you need to know for the exam because it makes it easier. And not just that, when you're ready to do the AWS Certified Solution Architect Professional, if you've learned it, all the foundations the first time, it'll be very simple. It'll be a single book, and that book is completely free to you. So please read that book, download the book, and it'll be emailed to you. Now, also, when you go on job interviews, on a solution architect interview or a cloud architect job interview, when it comes down to getting hired, they're going to ask you to talk about how the technology works, why I should use it, etc., etc. They're not going to do hands-on configuration testing on you. So I want to make sure you understand the technology. For a cloud architect or a solution architect, if you don't understand the underlying technology, you can't do the job. We don't code, we don't configure. Now, cloud engineers do. And for that, we have free labs that we want you to do. I want you to get hands-on technical. I do. With our time together, I want to make sure that we can train you, we can educate you to get you one step getting closer to getting cloud hired, which is what we do around here. So please download the labs. Sign up for the labs. It'll be on our content delivery systems. You'll get access to them. We're going to talk about the concepts, how the pieces and parts fit together, and give you the knowledge you really need. And then you can do those hands-on configuration labs. They're completely free. They're demoed by Leo from my team. He's fantastic. So together, we're going to work on knowledge. And the way we're going to do this is as follows. I'm going to talk for about 20 minutes, and then we'll do approximately 10 minutes of questions. And in between, my team, the best they can with questions. There's 6 people on my team in the chat box right now and potentially more that are going to be there. Now, let's talk about this. Now, let's talk about some other cool stuff we have to help you in cloud computing career. Tonight, at 6 p.m. Eastern, I know it's going to be late for some people in other parts of the world. We have Delroy Batt. He's an amazing student of mine. Now, many of you guys come to our Head in the Cloud show, which is going to also be a podcast very soon. And you come and we bring in industry leaders. We talk about getting hired, getting promoted. Now you're going to hear from 25-year-old Delroy Batt, who's a fine young man. He came to me approximately a year ago. He was an emergency medical technician working on ambulances. He wanted to work in tech, and he'd been on about 20 security interviews, and nobody had any interest in talking to him. They all said, come back when you have more experience, which means he didn't do something right. He was in my program 3 weeks later. He had multiple job offers and worked in security, and he's just gotten his first cloud security architect job at an incredibly great organization. And he's going to tell you how, with just an associate's degree and no background or experience, we took him and got him his first cloud architect job, so he got a cloud hired. We do it all the time. We can do it for you as well. So join the webinar show tonight, and you'll know why he got hired. And if you want to train with us, great. And if you want to train on your own, that's still fine. But you're going to know what he did and how he trained differently than a certification provider will tell you, and that's why he's got hired. So I want to make sure there's that. This Thursday, I'm going to have my famous How to Get Your First Cloud Job webinar, and it'll be live on Zoom, and it'll be completely free. And in this, I will tell you to do the following. I will tell you how to leverage your life experience to show the hiring manager that you are right for the job. I will tell you exactly what the hiring manager desires. I will go over the job completely so you know exactly the skills. I will tell you what certifications you need to help you get an interview, because certifications themselves don't get you hired. I will tell you how your resume needs to look to get you brought in for an interview. I will tell you all the network and data centers things that you need to be good at these jobs, and I will tell you how to get hired. And then I'll teach you how to skip HR and get your resume in the hands of the hiring manager. All in all, people come in thousands from all around the world, and it's completely free. We guide people, and people tell me they're getting hired all the time. Either our students or not. Our students always get hired, but there's that. Or constantly get hired, I should say, assuming they do the work. Now, 2 more things we're going to do to help you with your career, and then we're going to get to the content. The Go Cloud career students, literally speaking, have to say no to recruiters and hiring managers constantly because they're getting bombarded by interview requests. And here's the reason why. They have the perfect brand. They have the perfect LinkedIn profile. They have the perfect resume. Now, resumes don't get you hired, but they do get you an interview. They get you that interview. So we are experts at tuning resumes for cloud architect and cloud engineering type positions and network engineering positions, so that your biggest problem will be, how can you tell the recruiters that you're not ready for the job yet because you're still in training? So I've made it really cheap in order to do this. My team realizes that people are struggling out there right now. The economy is kind of challenging. Inflation's high. So raise your income, raise your salary, increase your potential, and you'll get there. So very inexpensive LinkedIn and resume workshop that we're going to be doing. The link for that is in the description below in the chat box. And I guess one last thing that I'll mention while we're at it. My team and I have brought back the 30% off coupon code potential. The reason we brought back the 30% off coupon code potential is we know how hard it is for people to get their first job. We know that with the right training, it's easy. With the wrong training, it's near impossible. We want you all getting cloud hired. Our students get cloud hired constantly. And it's the best part of my day when someone says, hey, Mike, I just got cloud hired. You're going to hear a lot more about that tonight with Delroy, but please do that. Now, we're going to have some fun with this AWS Certified Solution Architect Associate 2022 Bootcamp. And it's going to be a lot of fun. But I'm going to ask you one thing, a little quick favor from you all. To put together a production like this, it takes 7 teammates from my team. We use production-grade video cameras. We use things that cost as much as a car every single time we produce one of these things. And we do it to help the world get cloud hired. We want to help you when we care. Could you help us share our mission of free training by liking and commenting and subscribing to this channel? And or maybe send a tweet, send an email, make a quick LinkedIn post that says, here, I'm attending free training, please join us. And the more people do that, the more people all over the world that can't afford training now have access to training, because the algorithms will tell people. So if you're willing to, can you make a quick LinkedIn post, a quick tweet? I'm enjoying this training. I want you to enjoy it too. I want to spread the word. So if you're willing to do that, please take one moment. I'll give you 1 moment, and then we're going to get to the content. But please spread the word of free training. We want to help as many people as we can. And then, about 30 seconds from now, we're on this. So let's talk about this. And actually, we're even starting to live stream on Twitch. So follow us there if you're a Twitch subscriber. Please do so. So hopefully you guys had a chance to exchange some information. And we're going to talk about the AWS cloud and how it is organized. And that's going to be the first part of what we do. So let's talk about the architecture of the AWS cloud. The AWS cloud is going to be comprised into 4 things: regions, availability zones, local zones, and edge locations. So we're going to talk about all of them. Now, when I like to see a region, I think of it as a huge geographic area, like a continent or a part of a continent. That's what a region is, a huge geographic area. And we also, in each region, have our data centers, for example. Now, the data centers that we're dealing with are going to be called availability zones. And I'm going to show you this in a picture in a minute. So think of it this way. Huge geographic area equals a region. Data center in the region, in which we'll have many data centers, consider them to be an availability zone. Now, next, and we'll talk about it in more detail in a minute, I'm just introducing the concept, we're going to talk about local zones. So if any of you have a networking background, which is a perfect background for this, you'll know that when things are in your data center, they're fast, 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 fast. And why are they fast? Because there's almost no latency because you're kind of in the same building. And when we go to the cloud, it gets slow, 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 slow. And a lot of that has to do with the latency over the wide area network connection. So organizations, realistically speaking, have two choices. Put the performance in the data center and stick everything else in the cloud. Or they can do this. They can keep some of the performance in their data center, some of it in a data center near them that's owned by the cloud provider, and some of it on the cloud provider. That's a local zone, and we'll talk about that architecturally in a minute. And actually, and then we'll talk about edge locations. And with regards to edge locations, we're talking about the location of the content delivery network and where they actually are. So now that you know that, you understand what we're talking about. The region is a large geographic area. A data center availability zone is a data center in this large geographic area. A local zone is an extension of a region to run latency-sensitive applications close to the user, and edge locations are in most major cities, and that's part of CloudFront. While we're at it, I'm seeing all these AWS trainings. And Mac, AWS training. Akash, AWS training. If you're having fun, type in AWS training. Young Park, AWS training. Fantastic. Venkat, AWS training. I'm seeing these great messages. Karthi, AWS training. Midnight Rose, AWS training. I'm loving it. Malik, AWS training. Mr. Gee, AWS training. And Marla, AWS training. So if you're having a good time, put in AWS training in the chat box. Makes us all kinds of happy. That way we know you're here, you work, alert, and oriented ×3, person, place, and time. So I'm seeing all the AWS trainings come in. It's great. How I love it. AWS training, AWS training, AWS training. Fantastic. Now, Chris, let's come back to the content. I'm going to be watching these AWS trainings coming in the side, and the more of them I see, the happier I get. So super excited to see them. Now I know everybody's awake. So Effie, fantastic AWS training. So now let's look at it visually, what we're talking about. So when we talked about this, I talked about the large geographic area being a region. And then I talked about the data centers inside the large geographic area be called availability zones. So that makes sense to you. Got this geographic region. And there's multiple data centers. And of course, these data centers are connected to each other with what? High-speed networking. 100 gig links, 10 gig links, multiple links bundled together in link aggregation groups. And we talk about the LAN and talking about, we'll get to that to some degree. So now let's talk about the local zone. And I'm going to architecturally show you that. Remember, when it comes to performance, you often have latency as an issue. Now, here's the thing with latency. You can't get faster than the speed of light. You just can't. So if I've got a wide area network between me in Palm Beach and Fort Lauderdale, it's pretty fast because it's not going a large distance. Now, if I've got a wide area network between me and Palm Beach and Ohio, now we're dealing with 1,000 miles, a couple of milliseconds of latency. Now, I want you to think about it this way. There are applications, say financial trading applications, which buy and sell a stock based upon what's going on in the news. And if, for a bank, they can buy a stock when it's going up a nanosecond faster than their competition, they can buy it cheaper. And then if the stock is going down, if they can sell it a nanosecond faster than the competition, they can make money by saving money on the down. So performance in these environments is great. Now, if a nanosecond can mean hundreds of millions of dollars a year for a bank, and now we've got a 3 millisecond link to the AWS cloud or the Azure cloud or the Google cloud, we've got a problem. So we need to do the following. Not use the cloud, and the cloud has some great things to offer. Scalability, performance, agility, digital transformation, it's exceptional. So we want to glean those performances. And at the same time, how do we get the latency? Well, we're going to use an intermediate data center, a data center between us and the cloud. So maybe perhaps I'm in Palm Beach. There's a local zone in Fort Lauderdale or Miami. I put my low latency things there. And then I still have my cloud, maybe in Ohio or wherever. So that's what we're talking about with local zones. So it's an extension of a region to run latency sensitive applications close to the user. It enables you to put your computing power as close as possible to the users. Now, in order to use them, you're going to have to opt into something called a local zone. And then what you'll do is you'll create a subnet in the local zone. And here in that subnet you create is where you're going to put your virtual machines, otherwise known as EC2 instances. You'll put your load balancers, like your elastic load balancers. You'll put your container service, whether it's like a Kubernetes service or the proprietary container management service, which we'll talk about throughout this. And even some of these local zones offer more. Some offer like Elasticache, relational databases, and high performance file systems, etc. So there's pretty cool stuff that we can do here in these local zones. And that's what they're for. So I'll show you the way AWS would describe it, and then I'll show you the way I would describe it. AWS likes to talk about enabling your local zones, expanding your virtual private cloud or your virtual data center to this place, and that's where you can run and build your low latency applications. Personally, this is the way I look at it. I look at here, you've got your big region, which is your large geographic area. Then you've got your little data centers called availability zones. And then you've got these local zones, which are really just a midpoint between you and the cloud. It's a local zone. It's another local data center, and it's nothing more than that. So now you kind of have an idea what's going on with these locations. So let's talk about edge locations. And edge locations are for the Content Delivery Network Cloud Front, the AWS proprietary Content Delivery Network, which is a good content delivery network. Now, content delivery networks, and we're going to talk about them a lot more, are not just caching servers. It's a private network plus caching servers. And the reason these things work so well is the network, not just the servers. So I'll show you how these things work and edge locations work. And then when we get to the CloudFront section, we're going to spend some real time on it because you're going to see lots of test questions on it. And content delivery networks are critical to performance, latency, scalability in your architectures. So let's kind of talk about this. So the edge locations are going to reduce latency. They're going to promote website scalability. They're going to reduce your load on the servers, and they're going to promote some DDoS protection. And we'll talk about that in depth another day this week. But for right now, let's just talk about this. Let's look at the way the edge locations look like architecturally. And then after that, I'm going to show you how they actually function. And that's really the key. So let's look at them architecturally. You've got your region, again, this large geographic area. And you've got your data centers, and that called availability zones. You're not going to forget availability zones and regions after this. Next, after this, we're going to talk about edge locations. The edge locations are where your content delivery network is. So what'll happen is when we've got users that want to connect to the website, what's going to happen is going to be as follows. They're going to hit the edge location, and hopefully the content's there, and get the response. So now let's functionality. Let's look at how it works. Hi, I'm a user. I'm user blue up top, the square user. Now over here, I want to go to a website called www.nonithecat.com. One of the people on my team, she's got a beautiful cat named Noni, and I want to go to the website to see nonithecat.com. So here's what I would normally do. I'm user blue. User blue types www.nonithecat.com in his or her browser. Now, instantly, there's a DNS lookup that matches nonithecat.com to my local edge location for the content delivery network. I'm over here, Mr. User. I go from Mr. User over here to my edge location. And if somebody that day already went to nonithecat.com. Guess what happens? The edge location sends me the data directly. So the user hits the edge location and gets the beautiful photos of nonithecat.com, and the user's very happy. Life's good, right? Now let's pretend, for example, nobody in Palm Beach County went to nonithecat.com that day. Here's what happens then. I've got the user. They get sent to their edge location. At this edge location where they're already at, Noni the cat's not there. So then the message gets sent across a private network owned by Amazon. A private network owned by Amazon, which has guaranteed performance compared to the internet, which is unpredictable performance and unguaranteed performance. So that's kind of what we're dealing with there. So then the content gets to the edge location, sends it to the servers. The servers now respond. And as soon as the servers respond, guess what? The servers respond. They send the information to a regional cache to the edge location to me, the user. Now, Chris from my team on the same day wants to see Noni the cat because she's a beautiful cat that Abigail from my team has. So then here's what happens. Chris goes a user in the same geography. He goes to the same edge location. None of the cats there. Then my wife loves cats. So my wife goes to that edge location and she gets a picture of Noni the cat. Then my brother, who I'm so lucky is visiting me from Philadelphia right now, is here in my house. And he wants to go to Noni the cat. So he goes and hits the edge location and he gets it back. Note, the servers only responded to the first one. All future responses were done by the caches at the content delivery network. So we have lower latency from using a private network. And next, what do we have? We've got caching to reduce the load on the servers. So as you can see, content delivery networks are hugely important to us. Hugely important to us. And we will be spending a lot of time talking about content delivery networks, but I wanted to introduce the concept. So now you know, what is a region? What is an availability zone? What is a local zone, which is a local data center for edge computing, and edge locations, which are the place for the content delivery network. Now, we're going to introduce the concept of the virtual private cloud, and then we'll stop and answer some questions. So first, what is the virtual private cloud? And when you talk to people that have a huge architecture background, they're going to call it one thing. And when you talk about people that have certification as their only training and they really don't know architecture, networks, and data centers, they're going to call it a virtual private network. But it's not. A virtual private network is when you carve a private network in a public network. By comparison, what we're talking about here is as follows. We're talking about your virtual private data center on the cloud. And in your your data center, what are you going to have? Your wide area network and your local area network, your servers, your storage. That's your virtual private cloud. So it's realistically speaking, it's your virtual private data center. Bear with me. I thought I had my phone on mute and it's beeped 6 times in the last minute. I don't know if anybody could hear it, so hopefully not. So let's really look about why it's your virtual private data center and what's really going on. So here you go. You're in an Amazon environment or a Google environment or an Azure environment. It doesn't matter. They all have the same concept, whether they call it a VPC or a VNet. It's all the same thing. This large area in the gray is the AWS data centers. That's it. The AWS data centers. In the cloud. So the cloud here is AWS data centers, their network, etc. Now, when they rent you their network and data center, they've got to keep your data center traffic separated from somebody else's data center. Okay. So how do they do that? They use a software layer and create you your own virtual private data center. And they call that virtual private data center your VPC. Now, that reality is the VPC is just a virtualized data center that you have. And all of your things that matter are going to be put in your virtual private data center. So you'll create your VPC, virtual private data center. Then you'll create your subnets. and then you'll set up your routing tables, and then you'll put your servers in them, put your storage in them, etc., etc. That's the same data center that you would have anywhere on and off the cloud. Now, what's different about these environments? It's the same virtual private data center. You do the same thing, all the same. So now it's just virtualized. That's it. It's just virtualized. Nothing else is different. And we'll get much deeper into this. Who knows? We may do some workshops, etc. together. Let's talk about the generically the kinds of architectures that exist for cloud models. We've got the following: a hybrid cloud, and we'll talk about that. We'll talk about a pure cloud, and we'll talk about multi-cloud, because that's the reality in today's world. There are the three kind of clouds we're dealing with. So let's talk about first, what is a hybrid cloud? Now, this is what a hybrid cloud looks like architecturally. You've got your own data center here, and you're also using the cloud. Why is it a hybrid cloud? Because you've got a data center plus cloud. That's it. So let's talk about why we might want to use a hybrid cloud. Your performance is almost always going to be better in your data center than the cloud, because we don't have a wide area network. Additionally, on the cloud, when we talk about block storage later, and realistically speaking, what you're going to notice is block storage is really slow. And the cloud providers will tell you it's really fast, but when we actually talk about drive performance, it's really slow. So when it matters and you need high performance, you need something better than block storage. Now, in the cloud, you don't get much better, so we'll talk about RAID and things that you need to do and how to optimize block storage so it doesn't perform so badly. But in the data center, you've got better disk performance. In the data center, you don't have to use a hypervisor if you don't, which improves your compute performance. In the data center, you don't have the wide area latency. Now, why, if the data center better, are we going to the cloud? Well, digital transformation, business agility, scalability, it's well worth it. So a hybrid cloud enables us to do the following: have the best performance we actually need, really good levels of performance, and at the same time get the scalability, business agility, and all the things that the cloud does well. So think about it this way. So that's what a hybrid cloud is: data center plus cloud. Now, cloud architects like me and my team do the following. They build private clouds in the data centers, things like an OpenStack cloud or a Nutanix cloud, and everybody major has them. American Airlines has them, for example. American Express has them. They have their own clouds. Even Verizon and big service providers, they have their own clouds, and then they connect to public clouds. So that's what a hybrid cloud is. It's a data center plus a cloud, et cetera, et cetera. And what's the benefit of this? If the cloud provider goes bankrupt, for example, and they won't, but you don't have to worry about that. If the cloud provider says, I don't like your business, and they've already done this to other organizations, and they go down, company's data center is up. If the cloud provider gets hacked, has a control plane failure, and has a network failure, the business is still operational. So better redundancy, better performance, and better availability. So a lot more complicated management, so et cetera, et cetera. Keep it that way. Now let's talk about a pure cloud. Here, I pick one cloud provider, and I put everything in that cloud. I believe the cloud provider is strong enough, resilient enough. I need high availability. I use 2 regions, 2 availability zones per region. And guess what? Everything's on the cloud. Now the cloud's more scalable. The cloud's more agile, et cetera, et cetera. So we've got that. Kind of keep that in the back of your mind. That's how that works. So agility of the cloud. Now think about it this way. All the clouds had outages last year. And those outages weren't necessarily constrained to a region or availability zone. Some of them took down the entire cloud. So the risk of being in a single cloud is as follows. The cloud provider kicks you out, poof. The cloud provider raises your rates, and you've got no negotiation or bargaining power because you're not in multiple clouds. Or the cloud has an outage, like AWS had 4 outages last year. Several of these outages affected the whole world, not just an availability zone. That's why 87% of businesses are on multiple clouds at this point, and many more plan to be in the future. So pure cloud is dumping all your eggs in one basket, the equivalent of investing in a single stock. We architects always use multiple service providers for WAN, etc. We would never do something crazy like that. So then the next architecture is multi-cloud. What's this? Put some of your stuff in AWS, some of your stuff in Azure, some of your stuff is in Google. AWS goes down, who cares? Azure goes down, who cares? Google goes down, who cares? And mind you, all these service providers are amazing. They're excellent at what they do, but invest in a single stock and something goes wrong, your portfolio goes to zero. So we don't recommend this. So we always recommend multi-cloud or hybrid cloud multi-cloud, and a hybrid cloud or multiple clouds. But those are your three primary architectures. I know I babbled for a little while, so I'm going to answer some questions. So if you can do the following. If you've not liked or commented or subscribed yet, please do so. Please like, comment, hit the bell, and give me a hashtag AWS Certified Solutions Architect Associate. Give me a hashtag that in the chat box, and then Chris from my team is going to come up and feed me some questions that I can answer. Please advise if local zone means on-prem. Absolutely not. On-prem means on-prem. Local zone is the data center between you and the cloud provider. So no, on-prem is on-prem. We use the local zone to get closer to on-prem performance by sticking a data center closer to our systems than the cloud. Angelo, what are some strategies to ensure the efficient cache use? Angelo, we were going to get a lot into that when we do CloudFront. And we're going to talk much more about cache hisses and cache misses, etc. Great question, though. What are some advantages of using content delivery network for dynamic content? This is where it gets kind of interesting. If the content is rather static, the content delivery network is really helpful. If the content is constantly changing, the content delivery network can actually make it worse. So here's where it would make sense, Angelo. So if I am a big media star or a big celebrity, for example, and I'm going to produce a new photo every 2 hours, if we set the TTL of the content delivery network to expire every 2 hours, it will still help. Because when I'd produce a photo or a video, it wouldn't have to have 3,000 millions of server hits. It would just be done once or a couple times, and then the content delivery network would take care of it. But if the content is really dynamic and changes constantly, it might not be beneficial. And it depends on the views of the content, how frequently it's viewing, and how frequently it's changing. Angelo, you have very good architecture thinking. Very good architecture thinking. Layla, what's the difference between an edge location and a region? Okay, so here we go. We've got a region, large geographic area. Inside of that region, we have data centers called availability zones. Now, there's something called the content delivery network, which is what we use to connect our web services to local geographies. Where the user connects to, that's the edge location for web requests. But where our compute power, our data centers will do much more than just web requests. We'll have HR systems, backend systems, storage systems, etc., databases, and that's not the kind of stuff we want to push to the edge location. Edge locations are just for web traffic, consumer-based web traffic. What we're talking about here is actually the actual data center and the actual servers. Good question. Is the local zone the same as a data center? It sure is. It's going to be a building that holds servers and routers and switches, just like any cloud provider. It's just a data center. Excellent question, Helen. In what way do CDNs increase security? Richard, great question. So I want you to think about this. If I were to send 1 million requests to a web server right now, and my web server could only handle 100,000 web requests, but I were to send 1 million good ones, then the content delivery network would scale it up as needed. Now, if I only had that capacity of 100,000 requests and I sent 1 million requests, what would happen is we'd be hit with something called the DDoS attack, or distributed denial of service attack. And that would knock out my servers and crash them. By comparison, in a common distributed denial of service attack, we send huge numbers, millions and millions of half-open TCP connections and illegitimate requests, bad requests. Now, those requests hit that web server. And when they hit that web server, here's what happens. It can damage the web server. Now, a content delivery network, I look at the bad replicas and say, you're not even allowed to go to the server because it drops them right then and there. So that helps dramatically with security. So we're dealing with, those are two mechanisms that content delivery networks really help with security. Great question there, Richard. And I'll actually answer Kay Kellis's question and after James Young's. What's the difference between pure cloud and cloud native? Pure cloud means you're all in one cloud. Cloud, and you can bring in your virtual machines from your data center to the cloud, like in a lift and shift environment, James. And if something happens with a cloud provider that's not good, you can pick up your virtual machines and move them to another cloud immediately. Cloud native is you pay millions and millions of dollars to reconfigure and redesign your applications to run in a serverless environment. Now, when you're running in a serverless environment, you have less to manage because the cloud provider does it for you. Now you have less control over your performance, less control over your security. And if anything happens in your one cloud, and you got a problem, you're in trouble. Now you could go cloud native and more of a Kubernetes open standards environment and sort of manage your own Kubernetes clusters and not using the ones managed by the providers, and stick your virtual machines on, stick your containers on servers which you manage, and that you could do, and that's mostly cloud native, partially not. And you can do that across 3 data centers in the cloud. Let's go to the next question. Is the edge location the same as the local zone? Nope, they're completely different. Remember, region, large geographic area. Availability zone, data center per region. Local zone, a data center that's closer to you than the primary cloud data center. And an edge location is where you access the content delivery network. So completely different, John. Hope I answered your question there. And for the person that did ask the question, does a cloud architect sit behind a desk and code? No. Cloud architects design, present, and sell. We don't touch the technology ever. We design it, present it, and sell it. Coding is not something we do. Configuring is not something we do. Sales presentations, negotiations, architectural designs, leading teams of 50 engineers, etc. Going to meetings, buying lunches, dinners, drinks, entertaining clients, and negotiating deals. That's what we do. And that's why people can't get hired, because they study coding and configuring for a job that's based on design, present, and sell. So for the people that ask that question, and so many, please come to the Thursday course and come to the class tonight where Delroy will teach you how he got hired. And he cannot code at all because he's an architect, not a developer. Difference between an edge location and a region: an edge location is where you keep your software. Your SART is where you access the content delivery network. The region is a huge geographic area for which houses, half a continent, for example. And there's data centers in there called availability zones. Local zones are data centers between you and the cloud, and edge locations are where you access the content delivery network. Two basic differences between AWS and Azure: none, zero, they're identical. If you go and build a cloud, you buy some servers, you buy some storage area networks, you buy routers and switches and firewalls and load balancers, all of it. Now, you install your cloud control plane. If you're AWS, you call your virtual machines Elastic Compute Cloud instances. If you're Azure, you call them Azure Virtual Machines. If you use object storage in Microsoft, they call it Blob. If you deal with object storage in Google, they call it cloud storage. If you deal with object storage on AWS, they call it S3. It's the same technology. So it's like, for me, if I write a prescription for Lipitor or atorvastatin, it's the identical drug. It's just one's a brand name versus a trade name. They're identical. Identical. Any other questions there, Chris?
Oh, yeah, plenty. You just got me lost by asking for a hashtag. So.
Oh, sorry about that. I'll do like 2 more questions. Then I'll probably ask for Chris for another hashtag, because that way I know you're awake. If you're awake, you're learning. I want to know you're learning.
There are a lot of questions about CDN, so I just want to make sure everyone's aware. We're going to be going into CDN in more detail.
Yeah, we're going to be spending hours on it.
So I'm not going to be bringing up any more questions about the CDN just because we got a whole section dedicated to that.
And I'll ask Ian Brett's question because I see it. Did you study to be a cloud engineer to become an architect? Well, if you wanted to be a doctor, would you go to law school? It's a completely different career. So no, don't study one career to be good at somebody else's career. You need different skills, different training, and different knowledge, and different background, and a different brand. Is on-prem the same as a private cloud? Well, we can have an on-prem data center that's a traditional data center, or we can install OpenStack software, Nutanix software, etc., and create a cloud in that on-prem environment, and then it's a private cloud. I can possibly do one more, Chris.
Sorry, I'm looking for a relevant one to the current content, so give me a second.
I think we can do one more.
Yeah, a lot of questions are about things that we're going to be covering later, like Guard Duty, CloudWatch, CDNs. This is just the beginning. Remember, everybody.
Yep.
We've only been going for 30 minutes. So most of.
Yeah, and we'll obviously be talking about things like CloudWatch and CloudTrail and security groups when the time is appropriate. It's part of our program, as is pretty much everything that needs to be there, and then a whole lot more.
I don't know if I've put it up earlier. There was a question about who controls the local zone. Did you answer that one?
Whoever's if AWS owns the data center, AWS controls the local zone.
Okay. Oh yeah, here it is. There we go. Yeah.
Here's the thing with the cloud: you can't go in there, knock on the door, and install your physical stuff. So that's because they do something complete more. They do it for you. Difference between edge locations and CloudFront locations, they're the same. That's where an edge location is a CloudFront location. But in AWS terminology, it's an edge location. I'm sorry, never mind. Yeah, an edge location is the same as a CloudFront destination.
All right. And like I said, most of the questions are related to content that we're going to be getting into deeper later.
So sounds good. Then let's talk about connecting to the cloud. But before we do, if in the chat box, you can do the following. Type in AWS Certified Solutions Architect Associate. One more time. Then I know you're awake, alert, and oriented. If you haven't hit the like button, please hit the like button. If you haven't subscribed, please subscribe and hit the bell. And make sure tonight you hear how Delroy Batt got hired. And it will explain to you why he got hired. And he will talk about why he did not become a coder at all to become an architect, and why they would have not hired him if he said, look, I have these skills versus them. So I want you guys to know it. And then tomorrow morning at 9 a.m., I will have another question and answer session dedicated directly to your career. Dedicated directly to your engineer. And for those of you that are engineers, realize you're going to need to do some configuration. So download the configuration guide, or at least register for the configuration videos that they're there. But if you want to be an engineer and not an admin, you need to know how this stuff works. So we're still covering it for you anyway. It's not good enough to know the name of a service and how to configure that service for any job. It's all about how the systems work. So let's talk about connecting to the cloud and why I love connecting to the cloud so much. If you got yourself here and the cloud's here and you don't have a connection to the cloud, there's nothing. You got nothing. Now, you could put an external web server on the cloud, but how would you manage it? You could do something really scary like create a bastion host, which is a security nightmare. We can talk about why we should never do that later. So without your connection, there's nothing you can do to manage it at all, zero. Now, if your servers are in the cloud and your users in your building, they can't access your systems, the private systems, over the internet. They can access the private systems over the internet, or you'd have to create a VPN for all your users. And that's not going to give you what you need in a lot of cases. So let's talk about connecting to the cloud. Once your stuff's on the cloud, you need to be able to talk to the cloud. And realistically speaking, there's a lot of things you could use to do this. You could use SSL tunnels. You could use IPsec tunnels. You can use software-defined networking. You could use SASE. You could use Ethernet over MPLS. You can use a private line, etc. But today what we're going to talk about is VPNs and private lines, because 90% of your wearing connectivity is going to be done on that. And that's going to go way beyond what you need for this. It's going to go way beyond what you need for the Certified Solutions Architect Professional, and we'll cover about as much here as you need to know for the AWS Advanced Networking, because if you don't know the networking in the data center, you don't know the cloud. So let's talk about what is a VPN. A VPN is when you've got a network and you create a private network inside of that public network. That's all it is. So imagine I've got a wire. My wire looks like this, and I want to separate Noni the cat's traffic from Cindy the cat's traffic from Sunny the cat's traffic. I do that, and I can do it on the private line. Now I could do this with IPsec tunneling, L2TP tunnels. I can segment them at layer 2 with VLANs. I can put them in a different virtual routing and forwarding instance, like we did in RFC 2547, the BGP VPNs. We can use any of these things. But we're going to be talking about IPsec VPNs, because that's the majority of what we're going to be using. So why can't I just send your traffic over the internet? Why not? Well, here's the thing. The internet's not secure. So if I send your traffic to the internet, hackers are going to be looking at your traffic. That's it. What about routing? If we really wanted to have good performance routing on the internet, and we're going to exchange a full routing table with the internet, we'd have 800,000 routes per service provider, for example. If we want a really good internet performance, multiple ISPs, etc. Now, not all routers can handle that. Heck, when you connect to AWS, they only take 100 routes from you. So can't think about that. Now, when you run your routing information, what's on this side and this side need to be on the same subnet. Now, they can't be on the same subnet across internet service providers, but they can with an IPsec tunnel. Now, also, anything on the internet needs a public address. Now, if you're dealing with an organization that's got 400,000 employees, there's no way they can get 400,000 addresses. There's just not enough addresses out there. So they're going to be used private addressing in each data center. What can't you pass over the public internet? Private addresses. So as you can see, you can't really do routing over the internet because of the subnetting, etc., etc. So think of it that way. We can't completely route over the internet. So what we have to do is either route over a wire, just a wire, or we can route over a private wire. So with VPNs, we're basically creating a virtual private tunnel or a private wire across the internet. And what it's going to look like architecturally is going to be something like this. Basically, what you're going to see is you've got your data center. And in your data center, what you can see is you're going to be connected to the internet. And through the internet, you're going to create an IPsec tunnel to the virtual private cloud on the other end. So basically, tunneling through the internet. Amazon's got their virtual gateway on their end of the internet. You've got your router sitting on your end of the internet, and you tunnel your traffic through it. Now, when you deal with IPsec, IPsec does a lot of cool stuff. It gets around the security challenges of the internet. It enables you to put your traffic over the public internet. And because it's inside of the tunnel, you can pass your routing information. But it does more than this. I want to send a message between my Cindy the cat and Abigail's Noni the cat. They look alike. They're both cute cats. They have the same black tabby pattern where they both have gray and white and a little yellow and blonde fur. And they look like little gray and black tigers. They're really the cutest cats ever. So two cats want to talk to each other. Now, Chris also has a beautiful, wonderful Maine Coon cat. So let's think about it this way. If Cindy wants to talk to Abigail's cat, Noni, and they want to talk about their favorite hiding spot to catch tuna fish, and they both go get their tuna fish together because they love tuna fish. And Abigail is telling Noni, hey, let's get our tuna fish together. And they both communicate in a secure manner. So keep that in the back of your mind. Now imagine Sunny the cat, who's his Chris cat. It's a big cat. It's a muscly cat. It's a Maine Coon. And let's say Cindy the cat and Noni the cat are scared, really scared of Sunny the cat, even though it's a beautiful cat. So when Cindy wants to talk to Noni, she needs to know that Noni's Noni and not talking to Sunny the cat, pretending to be Noni the cat and giving Noni the access to the secret, giving Sunny the access to the favorite fish hiding spot. Because what's going to happen? Sunny the cat's bigger and she's going to eat up all the fish. So I can determine who I'm talking to. Imagine a doctor writing a prescription for 2 milligrams of morphine for a patient having chest pain. And on the other end, for example, it got changed to 20 milligrams of morphine. Well, that would kill the patient. They'd stop breathing. So the next thing that IPsec does through use of hashing it, make sure that the message hasn't changed. If Cindy the cat sends message 1 goldfish, Noni the cat should see 1 goldfish, not 1,000 goldfish. So far, Cindy can identify Noni, which means authentication of the peer. Message integrity means we can make sure that the message hasn't been changed. Now, there's one more thing. One more thing. Here is what we're dealing with. We're making sure that Cindy the cat can't say, I didn't send a message. It's called non-repudiation. And I see the question in the chat box. Please look at the computer screen for access to the lab demos. Register in the chat box in the link. So yes, there's labs. We want you to download the lab or sign up for the labs and do them on your own time. We want to make sure you actually understand things so you can actually get hired. Because on an interview, they're not going to ask you to configure, but they will ask you to explain the technology. We need to make sure you understand that. So that's what we're talking about IPsec. Authentication of your endpoints. Making sure your messages haven't changed and making sure after the fact the person can't say, I didn't send it to you. So let's talk about what's good about VPNs. What's good about VPNs? What's good about VPNs is as follows. Everybody's got internet access. Everybody's got internet access. So it's pretty easy. I want to create a VPN between my Chief Operating Officer, Chris, and me. Chris connects to the internet. I'm already connected to the internet. We set up an IPsec tunnel between us. How long does that take? As fast as Chris's network engineer and my network engineer configure the IPsec tunnel. Minutes. So think of it that way. Now, if we went on a private line, which is going to give us better performance, and there's lots of regions we'll talk to about it later, it might take me 4 weeks to set up. I got to call AT&T, Verizon, or whoever the local service provider is, say I want a private line. Then they got to make the equipment there, put the termination equipment in both locations. It could be 4 to 6 weeks. A VPN I can set up in minutes. So that's the advantage of the VPN. Now let's talk about problems with the VPN. Performance. Internet traffic is not guaranteed, which means if Cindy the cat and Noni the cat want to talk, guess what? Maybe the internet's great and they can send videos of each other eating tuna and shrimp and scallops because they love it. But if the internet's not good and Cindy the cat wants to send a picture of her eating tuna and it looks and the message is lost and you see this, it's not a good message. So bandwidth is not guaranteed across the internet. Guess what's also not guaranteed? Latency. So this means we have absolutely no idea what's going to happen to our traffic on the internet. Do we cross 20 routers and 5 ISPs? Or do we get there in 2 milliseconds? We don't know. So kind of keep this in the back of your mind. So understand this. So no guarantees on the internet, etc., etc. Now, what is an AWS VPN? It's a VPN like any other VPN. There's no difference. And they typically are set up site to site. New York, AWS. London, AWS. Now, you could set up a multi-site VPN, New York to London, New York to San Francisco, and do it that way. You can do it if you wanted, just like any other networking thing. But when you set it, the way you set it up is you need to set up this termination on both points and the endpoints, And what's going to happen is data comes in, it gets placed into the IPsec tunnel, it gets encapsulated, sent across the wire, and received by the far end. That's all we're talking about. Now, once it's in the tunnel, we got the encryption, message integrity checking, with the hashing algorithm, et cetera, et cetera. Now, let's talk about availability of these things. Now, this is where, and performance. So what happens is we set up a tunnel. I set up a tunnel to somebody. Then what do we have to talk about? The encryption type, by the way. Encryption type. Because if I'm speaking encryption SHA-256 and somebody else is using, say, come up blank right now with an MD5, and we're not going to be encrypting because we're in a different algorithm. So kind of think of something like that. So we have to talk about the encryption type, the algorithm type, etc. And we can use BGP for routing. And if you guys don't know BGP, here's the thing. What you can do is as follows. You can use our, if you don't know how to use BGP, you can set up a static route. But if you've not seen BGP, please check out our free BGP workshop. We did it last week. Several thousand people attended. We did that as in preference of this to make you guys have an easier time of it. Now, I want you to understand the next thing, and I'm going to share this architecturally. AWS, when you connect to them, they will tell you that their endpoint, your virtual gateway, is high availability. And that's because it's there and it's a software device. But see, at your data center, your device is not high availability. So I'm going to map this out for you so you understand what I'm actually referring to, because most people don't see this. And this is why AWS saying their device is high availability is almost meaningless to us. If we've got a data center over here, data center, and then we're going to connect to the cloud block here. So the cloud's got a virtual router, which doesn't go down because it's a software device. It's logical. So let's call this your virtual router. This is a high availability device. Now, what AWS has said is, look, when you connect to them, their router can never go down, and it creates two tunnels between two separate availability zones. Here's your router. This is great, right? Well, let's think about next. Their router is high availability, yours is not. So this router goes down. Let's make it go down. Guess what? The link is down, and you've got nothing. So it's really irrelevant that their device is high available if your device is not, because you got a single point of failure. So what must this look like? You're going to need one router. And you're going to also need a backup router. It didn't need to do that. Hell, I did that. Let's copy this. Let's put another one here. Paste it. And you're going to need two routers regardless of what they tell you. And this way you can have one router that connects to their high availability virtual gateway, and another router that connects to another high availability virtual gateway. And then if either one of your routers fails, who cares? And the reason who cares is following. You got another one, but before you've got a single point of failure. So this is why the networking is so critical to cloud computing, because if not, if all you know is the name of the service and how to configure that, you're never going to know what to do and when to use it and how to use it. So keep it in mind that when it comes to performance and availability, 1 is none, 2 is 1, and 3 is greater than 2. If you got one router, it's going to fail. You got one server, it's going to fail. So at least 2 of everything. 2 clouds, 2 WAN connections, etc., etc., etc. How do you set up a VPN in AWS? Well, it's pretty easy. You determine which virtual gateway you want to connect to. And then you pick a routing method, a static route, or BGP, a dynamic route. We'll talk more about that another time. Set up your tunnels, tunnel source, tunnel destination. And you can use the default AWS protocol, AWS tunnel, or if you know something about networking and you want to tune it, you can make it yourself. You can create your own tunneling. This is perfect for network engineers. Better performance, more control, etc., etc. Now, if you don't know the AWS Management Console, you'll tell them a Cisco router, and they'll set it up for you. The configuration, router, BGP, etc., neighbor, whatever, remote AS, whatever, network, whatever, etc. They'll put it in for you. Or what you can do is quite simply hire the network engineer in your team to do it right. And you can monitor what's going on with your tunnels. Are they up? Are they down? Through any kind of monitoring tools, which we'll talk about CloudWatch, which is your native logging tool inside of AWS. Okay, so now we talked about private connections to the internet. Cheap, easy to set up, all good, right? Remember what I told you before. The performance is not guaranteed over the internet, which means we don't know if your traffic is going to get there or not. We have no idea. No idea, none whatsoever. So now let's think about them. If we need guaranteed performance, and I don't recommend anybody do the Network Plus if you need networking. It's way too basic and intro junior level. I see it popping in there. The CCNA is the bare minimum level, introductory level networking knowledge I recommend. And realistically speaking, we're talking about CCNP level knowledge to be a cloud architect. So I'd avoid the Network Plus. Nothing wrong with the certification, but it's too basic. And it's not going to help you get an interview. So kind of keep that in the back of your mind. So, and actually, you can just learn networking and not have any certifications, but I do like to see them based upon your background. And we can talk about that tomorrow in the question and answer session or in the Thursday, how to get your first job webinar. And we do these so people don't waste their time on things like that. So now let's talk about networking. If you need guaranteed performance and we really want it to work, we want to use a direct connection, which is a private line. A private line is a wire. The latency across this wire is the same. If I buy a 100 gig wire, I always get 100 gigs. If I buy a 1 gig wire, I get 1 gig. It's not like the internet, where I can have a 10 gig connection to the internet and get 10 gigs of throughput, 1 gig of throughput, and no throughput based upon the internet. So if you need guaranteed performance, you get a private line. AWS calls it a direct connection. The rest of the world calls it a private line. Azure calls it express route. I think Google calls it a direct interconnect. It's the same thing. It's a private line. Same private line we've been using for 40 years. It's a guaranteed reliability, highest reliability. Well, it can still go down, but much higher reliability, consistent latency, and consistent throughput. Now, thinking about this, you should never have a single point of failure, which means you should have multiple links. Now, if you get a 10 gig connection to the cloud provider, and that's not enough, you can bundle multiple 10 gigs together, links together. Now, in the old days, we called it port channel or Ethernet, and we were bundling ports together on a switch. Now, they call them the link aggregation groups. And AWS supports that. All a link aggregation group is, we take four wires together, and we bundle them together, and it makes it look like a big wire instead of a small one. Now, when we're doing these link aggregation groups, et cetera, we're talking about as follows. They've got to be the same speed. You can't mix a 1 gig and a 10 gig. So kind of keep that in the back of your mind. So we can bundle 1 gig links and 10 gig links. We can bundle 100 gig links, but the last time I checked, it didn't improve the performance like you would normally get here. Now, when you connect to the cloud, you're dealing with a fiber optic connection. So local to your data center, there's a copper wire. But copper doesn't go very far, about 100 meters. Now, when you need real performance and really high performance, you're not going 10 meters. You may be going 1,000 kilometers or 100 kilometers or 50 kilometers. We need something, so we're going to be dealing with fiber optic connection. And I'm going to also show you the weird way that these things actually look, because it's not straightly a private line. Logically, if you don't know what's going on under the hood, what your private line looks like as follows. You got your organization with a wire directly to the cloud. This is what it looks like, but this is actually not what's going on behind the scenes. What's going behind the scenes is as follows. We actually have this. The way this works is as follows. We've got our on-premise location, and we actually buy a wide area network connection, not to AWS, but to this direct connection location, which is going to be closer to us. And in this direct connection location, we buy the wire to a building. It's typically called the point of presence. We buy a wire to this building called the point of presence, and in the building, we've got our routers. Now you can see that in these buildings, we also have the AWS hardware, and that's the AWS switches. So what we typically happen is as follows. We get a wire from our data center to the direct connection location, And then we request, and we'll go through it, something called a letter of authorization, which enables your internet service provider or whoever your WAN provider is to run a cable between your router and the AWS switch. And then what happens is we send them a VLAN to segregate your traffic, and that will basically be backhauled back to AWS. So that's how it happens. You buy a wire to your location, then you get a letter of authorization to get what's called a cross connect, which is a wire between your devices and their devices, and then it gets backhauled or taken back to the AWS network. So let's talk about the underlying technologies that make this magic happen. So first, we've got a fiber optic connection. So this means your routers and switches need to have fiber optic ports. Now, if you ever worked with fiber optic connections and routers and switches, you'll know that you've got the device, you've got a fiber optic port, and then you need to put a laser in there. A laser in there. So think about that. So you need a laser to connect, to send light or photons across the fiber optic connection. So what we do is we buy the router with this port, then we buy the optic, and the optic will be based upon short haul or long haul. The optics that we're going to be used and the type of wiring we're going to be using are going to be as follows. For basic 1 gig, we will use single mode fiber, 1000 base dash LS with LX, which means long distance. So it'll be 1000 base dash LX. That's what we use for 1 gig. For 10 gig, we use 10 G base dash LR. Now, kind of think about this. Now, if you're like me and you've ever worked with lasers, you're going to know the following. You've got a send laser and a receive laser. And something that can happen is the send laser can go down and the receive laser can go up. And what will happen is the wide area network thinks it's up. And if the BGP or the interior gateway protocol doesn't shut it down for a while, you could be thinking the link's up and your data is getting lost because it has no place to go. So the good news is AWS supports bilateral link forwarding detection, a protocol that's 20 years old that says if the send laser is up and the receive laser is down, and you've got another connection, tear it down and use the other one. Or if the receive laser is up and the send laser is down, tear it up and use the other one. So we're really talking about a lot there. So now you know how it works. Now, as I mentioned, in order to connect your routers to the AWS network, we need that cross connect. And this requires a letter of authorization. So how do you get it? To get this wire to take you from your network to the AWS network, let's do the following. You request a letter of authorization, either via the management console, so API or CLI. And if your application is complete, meaning you did it right, AWS will provision a switch port on their switch in the direct connection location. And then you will download this letter of authorization, and that will enable, you'll get it, you'll give it to your service provider, and then they'll just run a cable between your switch and their switch, and you'll be good to go. Now, I know I'm giving you some detail into these connections because I want you to be able to get hired in the end. People are going to ask you questions. So I'm going a little deeper than a basic certification would because I want to help you. I want you to have some actual knowledge. So now let's talk about it. When you connect to them, you can connect to either a public interface or a private interface over your direct connection. So let's talk about what they are. A public virtual interface connects you to public AWS services, such as S3, DynamoDB, SQS, and public endpoints. You're going to need to use a public, global, routable address space on both sides. Why? Because you're connecting to public endpoints. And the way this works is you put your information into BGP, AWS will take your routes via BGP, and they won't be exporting your routes to anybody else. Think of it as using the BGP community export if you know about networking. If not, don't worry about it. They won't be exporting your routes. Now, when you're dealing with AWS, you can only send them 100 routes. 100 routes? I mean, think about this. 100 routes is nothing. You deal with an enterprise, and they've got 20,000 routes in the routing table. You connect to 3 internet service providers, and you get 800,000 routes from each one. AWS supports 100. So when you're dealing with AWS, this means your IP addressing scheme needs to be scalable, contiguous subnets so you can summarize and do route summarization and that means send it to them. So you're going to need some networking sophistication. Why do you think I'm letting you register for the lab? So I can actually give you some of the sophistication. Because teaching you the name of a service and how to configure that won't get you through any kind of an interview, because they're going to wonder what it is, how it works, and why a company should use it. And if you can say, I can click these buttons, they don't care. So you can demonstrate that after you get the job. But in order to get the job, you'll be able to show people you actually know something. So I'm trying to give you some more depth. So public endpoints get you to the public things. Let's talk about private endpoints. Private endpoints do the following. Connect you to your virtual private data center, otherwise known as a virtual private cloud. Since it's private, you can use your own private addresses. And again, 100 routes over BGP. So think of this, 100 routes over BGP. So you're going to need a good IP addressing plan, good routing, plan it out ahead of time. This is not the place to be using a subnet calculator. This is the place to make sure you've got somebody that knows what they're doing, helping you with the IP addresses. So let's talk a little bit more about link aggregation groups. Link aggregation groups enable you to bundle links together, as I mentioned. And by doing so, if you put 4 links in a link aggregation group and 1 link goes down, you still have 3 links, the link doesn't go down. So you've got better availability and performance. Now, what is it going to look like? I'm going to show you right now. You've got your on-premise environment. Because we care, we've got at least 2 sets of connections, meaning 2 routers. Then we've got a link aggregation group where we bundle multiple links. So 2 to 4 private lines, minimum in one of these things per link. And then they get called back to AWS. So that's what we're talking about with the link aggregation groups. Now, I know I went a little deeper into networking than most people would do. And for the most part, I went deeper into networking than the AWS Advanced Networking in our introduction section because I want you to have the skills. So I can deal with some AWS or some questions so far. I've babbled for a little while. I want to get to your questions so we can help you. While we're at it, there's 681 of you and only 446 likes. Can you give me some likes, comments, and subscribes while we're at it so we can see what's going on with that, signal the algorithm that you're happy, etc., etc. And then, Chris, bring me in some things. But tonight, please, please, please join us and listen to Delroy Batt. Listen to 25-year-old Delroy Batt, who is an architect. And he trained to be an architect. And he was not spending hours and hours and hours doing configuration. He was not doing coding. He wasn't scripting. He wasn't working on Linux. He's an architect. And come and listen tonight why he got hired, why our students get hired almost every day. Listen to it tonight. And then, Chris, please bring me some questions. Which protocol is used to connect on-premise to the data center? BGP, BGP, BGP. There's no other protocols we can use because we're connecting our internal entity to another internal entity. That means the external connection, and we can use BGP. Now, internal to our data centers, we would use things such as OSPF, EIGRP, or intermediate systems to intermediate systems. EIGRP is kind of dying, but we've used those two. But connecting to others, we got a choice. A static route, which means as following. I connect to you, and I tell you the path ahead of time. And if the path changes, we're in trouble. Or I use BGP. There's nothing else that we can do. Good question, though. Good job. Why would you use a VPN if there's no guarantee? Excellent question. Speed. I want to connect a connection between Cindy the cat and Noni the cat, and guess what? I can do it in 5 minutes. I want to get a direct connection, and it's going to cost me 4 to 6 weeks of time. The next thing is I already have an internet access, and Abigail already has an internet access, so it doesn't cost us anything to create this connection in general. So it's generally cheaper to use a VPN than a direct connection. Now with the cloud, it gets different. See, generally speaking, here's what we have. Normally speaking, I buy a private line between my house and Abigail. Now, it costs me 10 grand a month for this 10 gig line between my house and Abigail, because trust me, those 2 cats are sending photos and videos of themselves all day long. Now, I pay the 10 grand a month for the connection, but I don't use it. In the cloud, here's what happens. I pay the 10 grand a month for the connection. Then I pay a daily fee for the connection. And then I actually have to pay to use the connection. Now, in AWS, they charge more to use your VPN than they actually use to charge your private line. So, for example, if you're sending a ton of traffic, say Abigail's cat wants to send uncompressed video at 300 gigabits per second to Cindy the cat all day long, and Cindy the cat's got a new special 8K video camera, and she does, and she wants to use that to send uncompressed video to Abigail at 500 megabit per second all day long, that I need a private line because it's going to get too much expensive. Edwin Schwartz, is the directional link something you get from your cloud provider? The direct link, yes, you have. You call it from your service provider, which means Verizon, AT&T, NTT, Telefonica, Etisalat, British Telecom, Orange, those kind of people. Good question. Does AWS only use BGP routing? Well, to connect to you, they have no choice. It's the only exterior gateway protocol they can use. Now, internally, I'm sure they're using OSPF or intermediate systems. I'm sure they also probably have an MPLS background. So they're probably using some label switching, some RSVP signaling to create some primary and explicit MPLS paths, et cetera, et cetera. So I'm sure of that, but which they won't tell you. But externally, the only thing they can use is BGP. The only exterior gateway protocol we have. Neil Smith, yes. If you got, you can look at it this way. Depending upon your traffic, if you need 40 gigs of low latency throughput, primary, you need 40 gigs backup, and a VPN is not going to be good enough. If you need 300 megabit per second over your private line, you can probably back it up with a VPN. So you're always going to need more than one and multiple routers. Do all service providers offer cross connect? You got to check with AWS who's approved and who's not approved, but most of them. Can I explain about AWS Trusted Advisor? Nary, of course. When we talk about AWS Trusted Advisor in terms of services that you may or may not want to use, yes, and what you can glean or benefit from that, we will cover that, but that's not part of the section that we're dealing with today. But we will definitely do it. We did this one already. If you decide to go pure cloud, then pure cloud should be multi-cloud. Is it much better than a data center on prevalence? Because you see a lot of difference in latency. Look, you're never, ever going to get to as close in the public cloud as you can do in the data center. In the data center, I can do, realistically speaking, I can create 8 million IPS in a server like nothing. I can deal with 25, 30,000 megabit a second for throughput on the cloud. I'd be dealing with such cost to do this. I mean, it would be impossible. I think the last time we checked, something that we could do for, literally speaking, a $100 drive at Best Buy costs about $30,000 a month on the cloud. So to get to that level of latency on the cloud is going to be really, really challenging. So data center, zero latency for the most part. Data center, maximum disk performance. Data center, we can run with or without hypervisors, which again gives us lower latency. Data center, we can run QoS on our network. Data center, we can do enhanced security things such as 802.1x, micro-segmentation, and layer 2 accesses. We don't have access to any of this in the cloud. Now, the cloud gives us the scalability, and with the cloud, we don't need a team of CCIOs like me to design it and manage it. So there's that. Kind of keep that in the back of your mind. There's that. So the cloud's easier. It scales better. It's often cheaper because you don't need as many complicated, capable people to set it up. So it's about using the right tech to solve a problem. How does an architect design their issues? And this is why you can't do reference architectures. And this is why we get projects irrelevant to architectures, because of the following. Architects design, present, and solve. And we do need to know all the things that are there. And what determines our architecture? The business requirements. The business requirements. The business requirements. And the business requirements will do the following. What is the business trying to achieve will make it clear. Can a VPN be breached? Soothing relaxations, anything can be breached. It's just a matter of how hard it has to be. But it's pretty hard to breach it. Apart from the VPN speed offers, is it also more secure? No, it's less secure. I want you to think about it this way. Here's a wire you own. It's just your wire. Here's something on the public internet, and you can break into it. Now, Helen, it's kind of interesting. Many of us have been using IPsec over a private line. And what that means, we run our private line and we run a VPN on top of it. Now, we've been doing this since 1998. It was the first time I implemented it. Last week, AWS had a major press release that they allow you to run IPsec over direct connection. It's not new, 20-some years old, but it's great to see the cloud is catching up day by day, getting closer and closer and closer to the network and the data center. Is an ISP the same as a cloud provider? No. An internet service provider connects you to the internet and provides internet services, your network. A cloud provider provides internet services, but also is your virtual data center. So that's where you put your servers, your containers, your storage, et cetera, et cetera. So network provider gives you network access, like your mobile phone provider. Now, George, you may find that your internet service provider, like Verizon, also is now offering clouds. And the first cloud that I worked on was in 1996. It was Frame Relay. That was a cloud. The next one I worked on was around 1998, called the ATM cloud. The next cloud I worked on was the BGP 2547 cloud around 2000. And the next cloud I worked on was the VPLS cloud around 2001. So clouds are not new. And the internet service providers were the first cloud providers. But really what they were talking about is you can't call AWS and say, I need a link between my house and London. They don't do that. You can call AWS and say, I want to get a virtual data center from you and put all my stuff here, et cetera, et cetera. Kind of keep that at the back of your mind. Does BGP changes implemented in everything takes time to converge. Everything takes time to converge. Would you need to use a VPN if using the direct connect? Well, if you've got a direct connect and a direct connect backup, no. But if all you have is a direct connect and somebody's working on the streets and they dig under the street with a backhoe and they cut your internet connect cable, then poof, you're down. Or like anything else, your service provider has an outage, you use one direct connection and you are done. So no, never. You will always need more than one connection. BGP is Border Gateway Protocol. BGP is a path vector protocol that's used for interdomain routing. It uses TCP/IP. The reason we use it is as follows. BGP is highly scalable and highly tunable. I can say, I only want to take in these two routes from you, and I can do it. We use BGP for the following. Inside of our organization, we use something called an interior gateway protocol that's optimized for speed. Cut a cable on 3 to 5 seconds later, it's working. But when we connect to the internet, we get 800,000 routes per internet service provider. And our interior gateway protocols that are designed for speed can't scale. And we also can't filter. So yes, BGP is used anytime you need to connect to an external entity, like a cloud provider or an internet service provider or an external company. For reliability, do you need multiple ISPs? Minimum on each end. So what you could do is, now Pradeep, this depends on how smart your network engineers are and how sophisticated. You could create 2 separate internet connections and try to run 2 separate things. Now, when you do this, it's going to get really ugly. You don't know where your traffic is going to be. So what you typically would do is you'd create 2 internet service provider connections on 2 separate high availability routers. You would run eBGP to each internet service provider and iBGP to carry the routes across. Pradeep, as it turned out, I did a 4-hour BGP workshop, and my team can post the link to this just last week. At least 2,000 people attended. So there's that. We can pop the link to that in the chat box. And I may be able to do 1 or 2 more. If a client has 2 AWS clouds, no, they wouldn't have 2 AWS clouds. They'd have an AWS cloud and an Azure cloud, or an AWS cloud and a Google cloud.
No, finish reading.
That may have resulted of companies merging would still be used.
So company A and company B already have their clouds established.
Well, what you're going to be doing is VPC peering, and you would be exchanging routing information via static routes or BGP. So yes. VPNs don't help with secure connecting. VPNs enable you to create a secure environment out of an unsecure environment. So encrypt the unencrypted. Now here's the thing, which is more secure? A secure environment, period, like a private line, or securing an insecure environment like the internet. So they do help, but nothing as secure as a wire if you own the wire. Now you can take your wire and you can encrypt both ends of your wire, and you can run a VPN on your private line. And for organizations that need critical security, we often do that. But realistically speaking, a private wire is going to always be more secure than trying to secure an insecure connection. Mike Obed, you want to be the next Delaware Bat? Come tonight and listen to what he has to say, or train you, and you'll learn the difference between certification and what we actually do in our real jobs. Cash, if I want to set up a direct line with AWS, do I need to contact your ISP? You need to contact whoever does your private lines, which may be your internet service provider, and it may be another provider. So, because small internet service providers may only do internet, and they may not do private lines. So you have to deal with somebody that offers private line. Will we be discussing the use of third-party monitoring tools? No, this is an architecture-based course. Monitoring tools are system admin work and maintenance work, which would be the realm of sysops. We're teaching architects and engineers, not sysops or maintenance roles. So no, we're not going to be talking about monitoring. How long does it usually take? About 4 weeks. Can we use a direct connection with VPN having IPsec to make the connection? Well, normally we've been doing this for over 20 years, 25 years almost since the first time I did it. AWS did not allow that until a month or so ago. They made a massive press release on it. So now the old technology is now brand new again with AWS. And the answer is yes, no, we can. Okay, so let's get back to the content. So please join us tonight for the Cloud Hired video. If you've not downloaded or at least signed up for the lab demos, please do so. I want to use this time to make sure you understand cloud and not just how to configure it. So you can do the configuration things on your own. That's simple, that's nothing. But knowing what to do, that's the hard part. So that's why we're doing that together in a question and answer environment. So sign up for lab demos and the book, because I want you guys to be great. Come to the Thursday free webinar so you can learn what you need to do to get hired. And while we're at it, we've got a 30% off discount for the coupon code potential, because I want you all getting hired, paid more than you can ever dream, and have the best lives. So let's get back to the content. But before we do, if we're at it, if you can give me a hashtag AWS Certified Solution Architect Associate in the chat box. And I'll do that. I'll know you're awake and not sleeping. If you've not liked or subscribed or hit the bell yet, please do so. I can see if you guys are doing so while you guys are giving me the chat box. Some of you are, but not enough of you guys. Only a couple hundred so far. We've had 4,000 people show up. I'm hoping to get to 1,000 new of you subscribed today. So please subscribe while you're at it. Coach Cleats, AWS Certified Solution Architect. Leonardo, AWS Solutions Architect Associate. Deepak, AWS Certified Solutions Architect Associate. Manoj, AWS Certified Solution Architect Associate. Marlo, AWS Certified Solution Architect Associate. Tejas, AWS Certified Solution Architect Associate. Marwan, AWS Certified Solution Architect Associate. And Alonzo, AWS Certified Solution Architect Associate. I'm loving this. Tyrone, AWS Certified Solution Architect Associate. And Effie, AWS Certified Solution Architect Associate. And Derek and Jessica, AWS SAA. I'm loving this, loving this, loving this. Leonardo Villar, fantastic. Raul, Gustavo, AWS Certified Solutions Architect Associate, etc., etc. I'm loving this, loving this, loving this. So I'm going to go back to talking about the content. While we're at it, everybody, tell me where you're from or where you live, whichever you want. My family's from Greece, for example, and I live in Palm Beach, Florida. We know Chris is over there in St. Petersburg. We know Abigail's around the Asheville, North Carolina area, I believe. We know that Chow's over there in Dallas. We know Eddie Patrick has been into Cameroon. We know, for example, that Leo's in Sao Paulo, Brazil. And for my team, we know that we're all over the place. So we love seeing where you're from. Cape Town, South Africa, South Carolina, Ghana, Dallas, Motown. This is great. Germany, Brazil, South Africa, India, Goa. Oh, I haven't been there in a while. Beautiful beaches. Nigeria, fantastic. Mexico, UK, South Africa, more. London. I mean, this is just incredible. More people in Argentina, lots of Cameroonians and Nigerians. I love that. Fairfax, Virginia, Nepal, Venezuela, Romania. Wow, Papua New Guinea, that's pretty cool. Manchester, UK, the Ivory Coast. Wow. Ontario, Cameroon. Collins, I know you're Nigerian, but living in Texas. Fort Lauderdale, Virginia, Sweden. Oh, I'm loving this. Nigerians in Canada, Nepalese, people. Sorry, I'm thinking in Greek. Bangalore, India. Wow, I haven't been to the UK or Bangalore in a long time. South Africa, more India, Louisville. This is fantastic. So I love why we're doing this. Just to let you know, I've got 1,000,001 things I can be doing, but I love how we've got people coming in from all over the world. Love, love, love it. Okay, so now we're going to talk about storage on the cloud. Storage on the cloud. And storage on the cloud is really important for the following reason. We've got all these servers and stuff doing stuff, right, everybody? Now, if we couldn't collect the data, guess what? What good would it be? We'd have all these systems running calculations based upon what? Upon what? So we need to store things. Now, when we store things, we're going to be typically talking about two things: volatile storage and non-volatile storage. Here's what volatile storage is. In your computer, you've got DRAM. You shut off your computer, the information goes away. In the cloud, you've got the storage that comes in the server itself, the instant storage. This is fast, fast, fast storage compared to slow, slow, slow block storage. Here's the problem. When you reboot your system, or I should say, when you terminate the instance or you terminate the computer, it's all lost and goes away forever. Imagine storing critical business information on something that could just evaporate like nothing. So we're going to talk about lots of storage platforms in the cloud. We'll talk about what they are, how they work, and why you should use them. And of course, you can configure them by downloading, or at least signing up for the AWS lab demos. And in the book, download the book while you're at it. So kind of keep that in the back of your mind where we're dealing with. Making sure this is okay. So now that you know volatile versus non-volatile, we're going to be talking about lots of storage types. First, we're going to explain the storage technology. Then we will explain the AWS specifics. And here's the reason. If you don't know what the tech is, and all you know is some silly name of a service and how to configure that, how do you design it? You can't. So we're going to talk about what is the tech. Now, when we talk about this tech, it will be applicable and work on all clouds. So I like to say, don't learn AWS, don't learn Azure, don't learn Google. Learn the cloud. Imagine this. Imagine learning how to drive a Honda and needing a new certification to drive a Toyota and needing a new certification for a Mercedes. That would be insanity, right? Well, getting 1,000,001 certifications would also be insanity. Learn the cloud the way you learn to drive. Learn the cloud the way you learn to drive. So the first kind of storage we're going to talk about is block storage. Block storage is a type of storage area network. Now, here's what happens. With block storage, we take the data and it gets broken down into blocks. Why? And each block is going to have a unique identifier. But why we use block storage is this following. Block storage is efficient. Normally, you got your storage in a server. Okay. With block storage, because it's a storage area network, your storage can be anywhere, wherever it's most efficient. So in my data center, we can have block storage. And I can have these big arrays, these big, huge RAID arrays filled with hard drives. That's block storage. And everybody can connect to them over the network. And that way we effectively decouple the storage environment from our server environment. Storage environment from the server environment, et cetera, et cetera. So now that we see this, kind of keep this in the back of your mind. That's why we're using it. We're dealing with taking our servers and our storage and decoupling them. Somebody from my team, if you can get rid of the nasty stuff that's popping in the box right now. So block storage decouples your environment. And we place the blocks wherever it needs. So think about a scalability perspective. It's going to scale well because if we need another storage and network, we call Dell EMC or IBM or whoever's making it, buy another storage and network, drop it in the data center, and now our servers can connect to it. So block storage is really, really scalable. Additionally, block storage is the fastest storage option we get on the cloud. It's not good. We'll tell you why later, but it's the fastest we get on the cloud. So keep that in the back of your mind. So that's what block storage is. It scales, etc. Block storage writes to the hard drives in a manner that's very similar to a regular hard drive, data written in blocks. And because of it, we will use block storage as virtual hard drives, and we're going to talk much more about it and show you what it looks like. Just keep that in the back of your mind. Now, the next kind of storage is object storage. Object storage is, again, another type of storage area network technology, but it's different. It's very different, and it works differently, and it's used differently. Object storage, the data is taken down, and data is broken down into objects. Now, here's what the magic happens with object storage. When the data is broken down from data into objects, you've got an object. Now, there's this thing called metadata associated with the object, which is data about the data. So now you got an object. It's a photo of Noni the cat. I've got metadata that says it's information. It's a photo of Noni the cat. Now, think about this. If I'm looking for thousands of photos of Noni the cat, and I've got some information about the Noni the cats, I can find just Noni the cat and not everything else. So that's one of the things that makes object storage so great, is the metadata. Let's talk about the scalability of object storage. Normally speaking, storage is hierarchical in an environment. Not with object storage. Object storage is really more like a data center than a database than storage. And here's the way object storage works. You got this object with metadata, and you've got a database pointer to the data. So even though you may create buckets and things to make it look hierarchical, this is flat storage, database storage. Information, metadata, and a database pointer. Wow, that's pretty powerful. So because of this, it scales. Pointer to the data. Now think about this. I want to do a query, an SQL query of my data. I can do it because it looks just like a database. I've got the metadata. I can view part of an object, not all of it. Do I need to download the full 5 gigabyte file, or can I only look at a percentage of it, 100 megs? So object storage is really efficient. But object storage has a problem. It can't be used by a server like a regular storage, and here's why. Let's say you've got a server that has 2 terabytes of DRAM in it. You've got a Unix system or a Windows system. 2 terabytes of RAM may or may not be enough for a big server. So servers have something called virtual memory or a paging file. And the virtual memory in the paging file does the following. It can act as RAM when needed. So typically speaking, your paging file is 1.5 times the amount of DRAM that's in your system. So you've got a server with 2 terabytes of RAM. You got a swap file that's 3 terabytes of RAM. Now, many of you guys know compute. You may know your swap file may change 100,000 times a second. Here's the problem with object storage. As soon as you take anything and it's modified by even a millionth of a percent, it creates a new version. So imagine a 3 terabyte file that gets done 100,000 times a minute. You'd be paying millions of dollars a month for storage just by using object storage for a single server. Eek, ugly. So object storage can't be used by traditional systems. So what can object storage be used for? Software distribution, video content like Netflix videos, for example, backup and recovery, archival purposes, etc., etc. So these are the things that we're really talking about. Object storage used for these reasons. Keep that in the back of your mind. So now you know what is object storage. Storage and network. Now the next kind of storage we'll talk about, and then we'll get into the specifics of the cloud provider, is file storage. Wait, got a hard drive in your computer? That's file storage. You go on your computer and you map a drive to a Windows system over the server message block protocol? That's file storage. You're in a Unix environment, a Linux environment, and all your systems are sharing files from an NTFS server. That's file storage. And realistically speaking, these devices can be mounted by anybody on the network. You got 20 computers that need to use something at the same time? Guess what we're talking about? File storage. So now you know the 3 storage types. And we are going to get into a very deep dissertation of AWS S3 or object storage in the AWS cloud. 99% of the things we're going to talk about on this are the same on the Azure cloud and the Google cloud. Only the names have changed. So before we do this, does anybody have any quick questions on the storage concepts that I just mentioned before we go into this? But keep the questions to the storage concepts. Other questions we can address at a different time. What about Glacier? We'll be covering Glacier because Glacier is object storage. How S3 handles parallel writes. We're not going to cover that because that's going to go into very deep engineering. And we're going to keep this, and it's way outside of the certified solution architect and professional. And we could talk about it, but that'll keep us derailed from the course. You said block level storage is like a hard drive. It's a network-based storage, and we can use it like a virtual hard drive. Virtual hard drive, not a real hard drive. If you have an on-prem cloud, do you have faster storage options than block storage? Oh my God. So we'll talk about how much faster. So right now, any of you guys that choose to go to your local computer store can buy a Samsung 980 Pro. Now a Samsung 980 Pro, which will cost you about $150 for a 1 terabyte drive, realistically speaking, will give you about 1 million OPS. Now, when you deal with block storage, a provisioned IO1 device, like which was the fastest thing about 2 years ago, we're dealing with 16,000 IOPS compared to our $100 device or €100 device that gives us 1 million. So we're not even in the same universe. Now, AWS is a brand new fancy IO2, which gets you to 250,000 IOPS. Again, which you can get at Best Buy for $150, or a basic computer store will give you 1 million. So there's, realistically speaking, no comparison between data center storage and cloud block storage. Difference between block storage and object storage. Well, when they're both storage area networks. Block storage places data and breaks it down into blocks. Block storage is faster than object storage. Block storage can be used for information that's received. Object storage, by comparison, cannot be used by computers. So it's not like we can put a database on block storage. Object storage is slower, and object storage is only used for backup and archival, software recovery, etc., because object storage is write once, read many times, because every time you create an object, every time you change something, it creates a new object, and it's just too costly to use it because of that, and it's very slow. A cache, working as a solution architect, you do not configure these services. Working as a solution architect, you design, present, and sell, which means no touching of the technology. Can we say S3 is a database? No, we can't use S3 for a database because computers can't use object storage. What is the drawback of using block storage? Speed and performance. It's slow. It's scalable as can be, but it's slow. What are ways to make block storage faster, Mashaba? Well, it's really pathetically slow. So slow is slow is slow is slow. But what we can do is we can do RAID 0 and RAID 10 environments, which we'll talk about, to try and work around the poor performance of block storage. But it's never going to be great. How many storage options does AWS offer? Block storage, object storage, file storage. The same as all cloud providers offer. They've got a few proprietary things as well, but they all do. How to sync 2 objects in different clouds? Same way we've done it for the last 40 years. We've got 2 data centers. And basically, you just synchronize your data through whatever your application is that synchronizes it. We've been doing it for 40 years. Syncing 2 data centers. How would I recognize and differentiate each type of object storage? I wouldn't at all. Object storage in AWS Azure, Google, Oracle, the same. In many cases, they're buying the same storage from the same people and they're just running their own software. It's identical. It's no different. If you're an architect or a construction crew, and I said that you needed cement, does it matter if you go to Billy Bob's cement factory, Home Depot's cement factory, Lowe's cement factory, Ace Hardware cement factory? No, you just want cement. You're dealing with performance. I need cement of a certain strength, a certain mixture. That's all you care about. Cloud providers is just, who do you buy your stuff from? Do you go to Bloomingdale's or Macy's to buy your shirt? Same thing. Any example use cases and the pros and cons? Well, yeah. If you need a virtual hard drive for storage, use block storage. If you need to do backup archival purposes, use object storage. And if you've got 30 users that need to use the same, 30 systems that need the same thing at the same time, use file storage. Do any of the storage types support encryption? They all do. They all do. Object storage and block storage. File storage, object storage, and block storage. Yes, 3 kinds of storage. Is block storage region specific or AZ specific? We're getting into those level details. I don't remember right now. Every time I do an architecture, because this stuff changes, I constantly look up at each time. I deal with 10 clouds constantly, private clouds and public clouds. So I always go to the manufacturer's documentation every time. What storage do you use for databases? Well, that's the only kind of storage that we can use as a virtual hard drive, block storage. So it has to be block storage. Is there a difference between block storage and ordinary hard drive? Huge. And at one point, I saw one of the AWS certification providers trying to demonstrate block storage in his local computer. And what it meant was he may be making AWS courses, but he has no idea what block storage actually is. So big difference. Ordinary hard drive is a hard drive mounted in the computer. Block storage is something that you reach over the network. So block storage is in some RAID erasing somewhere. Hard drive is a hard drive. So they're completely different technologies. The only difference is this. Similarity is this. The way the data is written to the hard drives is typically via some form of block. And whether that be a local file or a file server, it's still a block. So that's the only similarity which makes them look and feel like they could be used as a virtual drive, but they're not. What's the difference between EBS and EFS? Again, we're going to talk about block storage and object storage. And here's the reason why, Helen. If you go talk to a customer as an architect and say, elastic file systems, truthfully, you'll be escorted out of the room and your replacement will say, thank you for the nice job. And here's the reason. They're AWS marketing terms. As an architect, we're supposed to be a trusted advisor advising businesses on how to use technology to improve their business performance. I've got this elastic storage thing that's really cool. Mike, you're fired. Get out of the room. Here's the reason. The customer doesn't trust me. Now, and if I can talk to the customer and say, let's talk about your file storage. You're currently using Samba storage for your Windows on Linux for your Windows servers and NFS for your file servers for your Linux systems. And on the cloud, we're going to migrate you to the same server message box storage by setting up Samba shares for your Linux systems. And we're going to also use an AWS managed NFS service. They call it EBS, but it's the same thing, etc., etc., etc. Now you're an architect and you're not someone that looks like you've been certified and not knowledgeable. So you always want to talk about the technology. We always want to show the customers we understand their business, and we can never be too markety salesy, or they'll just kick us out of the room. Can we say an S3 database? Nope. S3 is like a database, etc., etc. And no, you can't use Athena to query it. You can use SQL queries. Athena is an AWS proprietary database. And by using AWS Athena, you're going to get yourself in a world of architecture problems if you need to do multi-cloud environments. And we can talk about what you can use and what you can't use in the real world versus your certifications when we come down to it in real world business environments. What do architects need to know between object storage sync? That's not our world. How do we design it? How do we design the systems to work? We are not hands-on configurers. We're not engineers. We're not admins. We are designers. How do I do this? Why can't you use object storage? Well, let's just take the swap file example I give you. We've got a swap file on a server. Server's got 2 terabytes of DRAM. Now, the swap file changes 100,000 times a minute. And the swap file for a 2 terabyte of DRAM thing is 3 terabytes. So realistically speaking, we would have a 3 terabyte object 100,000 times in 1 minute. So 100,000 times 3, we would have 300,000 terabytes per minute. And if you want to pay for that, you'd be dealing in the millions of dollars a month per minute. You'd be dealing with several millions of dollars a month. So not a good situation. Can file storage be used in a data warehouse? File storage is typically slower than block storage, so it depends on the speed of the file storage, but usually you use block storage for this. How does data encrypted in different kinds of storage? Whatever encryption algorithm you want to use. Although most of them support AES 256-bit encryption is the most common type. AWS say S3 bucket is global. Why do you need to select a region? Well, your bucket could be global, but here's the problem. If you've got a bucket in one region and your traffic is traversing multiple regions, AWS actually charges you for network transit. So if your stuff's headed in New York and your users are in Japan, what's going to happen is it's going to take forever for your users in Japan to actually get it because of the slow latency. But if you put the information in both, the users in Japan could get it, the users in the US can get it at a much lower latency. And by doing so, you'd most likely pay less inter-regional data transfer charges. That's why we're doing it. But good question. Okay, so let's do this. We're going to get back to the content. If you haven't subscribed, please subscribe and hit the bell to be informed of new things. Please like the video if you haven't. My goal is to get to at least 1,000 likes before the end of the day. Help me out here. And now let's get into the details and some of AWS S3. So what is Amazon Simple Storage S3? Basically, it's just object storage, which makes it the same as Microsoft Blob and Google's Cloud Storage. And it's going to be integrated into so many of the services that we have. It's relatively high availability storage, meaning it's available 99.99% of the time. What does that mean? You have it available except for about 50 minutes of downtime per year. Now, what I love about AWS S3 is the following. The durability of your data. It's 11 nines. That means 99.999 all the way to 9 decimal places. What does this mean? What does this mean? It means the following. Most likely you can access the data when you need it, except for 50 minutes a year. But once your data is there, it's not going anywhere. Meaning, it's most likely never going to get lost. So for this, we really enjoy that. We love that. Now let's talk about some use cases of using object storage. Backup and archival of an organization's data. Backup and archival of an organization's data. Static website hosting. Distribution of content, media or software, disaster recovery planning, and big data analytics. Why can we use object storage for big data analytics? Remember, we've got the following. We've got this metadata and the ability to run SQL queries, et cetera, et cetera. So now I'm going to give you some AWS details, the way they'd like to call it. Amazon S3 is organized into buckets. Each bucket is basically a container for files stored on S3. Buckets create something called the top-level domain space. What this means, they can be accessed by a globally unique, fully qualified domain name, meaning Abigail's cat noni.gocloudcareers.com, a fully qualified domain name. Now, the bucket names themselves can be up to 63 characters long, including numbers, letters, hyphens, and periods. And while you can generate a path, /this, 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 while that makes us users feel good about it, guess what? It's not where the things are stored. Reality is, we've got an object and a database pointer to the object. An organization can have up to 100 buckets per account without asking for an increase from AWS. You need to go above 100 buckets, you got to reach out to AWS support and they'll enable it for So now, how do you secure your data in S3? Well, you've got really two options to do it. We can do it via a bucket policy. Now, this is a relatively granular, scalable way to do it, and it's the preferred way to do it. It's going to work on identity access management, which is basically, who are you? What are you allowed to do, and then keeping track of what you've done, or basic permissions, like Linux would say. They call it an access list. Using the Windows and Linux term versus, to me, an access list is related to what subnets can talk to what from a networking perspective, but your focus determines, how you think of these things. So kind of think of this in the back of your mind. You can also base it upon an access control list, which gives you read, write, or full control. So let's go over it again. Bucket policy, very granular based upon who you are, what you're allowed to do, and keeping track of what you did, or based upon an ACL type where you can do read, write, and full control. Basic Unix permissions, basic Windows permissions. So now let's talk about the storage tiers. When it comes to getting your object storage, your block storage, there's different level of uses that you may need. And depending upon how frequently you need to access your data, there will be options that cost more or cost less for you. So there's going to be multiple storage tiers, which offer different performance levels and different cost levels. This will be on your exam. You need to know it, so we're going to go through it in some depth. We're going to talk about Amazon S3 Standard. And we'll talk about Amazon S3 Infrequent Access. Then we'll talk about Amazon Infrequent Access One Zone. Then we'll talk about Amazon S3 Intelligent Tier, and then we will talk about Amazon S3 Glacier. Beginning with S3. Standard AWS S3 does the following. It gives you relatively high availability, relatively high durability, and relative high performance. This is where you're going to store your data if you're going to access it frequently. So, frequently accessed data. So, we're going to talk about organizations' data. Let's say I produce a video on the www.gocloudcareers.com website. And the video is as following. How does BGP work? And I expect people to access that video on www.gocloudcareers.com all day, every day. I stick it on S3 Standard. And I don't pay upon each retrieval, etc., so it's the cheapest way to do this for this use case. Now, let's say after 30 days, almost nobody's watching the video for AWS, for whatever the video that it was on my system. So the video on BGP. So now I put it into something called infrequent access. And here, users that need it can still access it anytime they want. And I pay, typically speaking, about half to store my data here, but I have to pay to retrieve the data. So for infrequently accessed data, this is awesome. For frequently accessed data, this is going to get too expensive. So you, the architect or the engineer, needs to think about the use of the data and when to move and where to move and what it should look like. So keep that in the back of your mind. So with S3 infrequent access, it's still high availability. The performance is the same. The only thing that's there is now we're paying for retrieval. So accessed infrequently, yes, option. Access frequently, go to S3 Standard. Now, some organizations may say, for my information that I don't need that much, I can reduce the availability of it too. And that's where S3 Infrequent Access One Zone comes in. Instead of your object storage being across multiple data centers, or availability zone is just in one. Which means, guess what? Data center goes down, poof, your object storage is down. Now, if it's photos of my cat Cindy, no big deal. Unless Cindy's a celebrity and she's got a line of cat paws and cat fur, and she needs to be there. But my Cindy's not a celebrity. She's just a cute little cat that I went to the cat rescue to adopt, who I think rescued me because she made me so much happier. That's neither here nor there. So now you know when to use this. Now let's reduce availability, so I pay reduced performance. Now that means if I need the data, it may not be there. But the good news, the durability of the data, it'll come back. It's just another one. So S3 for standard, access information you're going to access constantly. Infrequent access, stuff you're going to access infrequently and you pay to retrieve it. Infrequent access one zone, you pay less for it. And because you pay less for it, it's going to be there when you need it. I see Mela Academy. I know Mela Academy. My friend Eric. Welcome, Eric. Eric's got some of the most beautiful dog I've ever seen. Haven't seen you, buddy. Hope you're having a good time in North Carolina. Hope you get back to Florida soon. So now let's talk about Amazon S3 intelligent tiering. What are we talking about over here? So if we allow Amazon's machine learning engine to do it for us, they're going to say, hey, there's this video that on BGP that people access constantly. Keep it here. Keep it here. So there's that. Next. Then there's this video that never gets used. Move it around to someplace cheaper. So we're letting Amazon's machine learning intelligence to move our stuff around automatically for us. And hopefully it works. Here's my rule. If you want it to work, don't rely on artificial intelligence. Set it up yourself. Manually set it up. It's my rule. But, this does it for you. And if you don't know, this is better than nothing. So the last thing we're going to talk about is Amazon S3 Glacier. What is it? Glacier is as follows. So you archive your stuff. When you put your information in Glacier, it's locked up. It's not immediately available to you for the most part. There's different versions of Glacier now. But with Glacier, typically speaking, you put your data on there and you pay the cheapest storage rates. Now you want it. Okay. Request access, and within 3 to 5 hours, typically speaking, you have access. So you pay so much less for it, but you need the data, you're going to have to wait. So kind of think about it this way. So let's look at life cycle management. I want you to kind of think about this. There are times in life where you've got data. So let's walk through, graphically speaking, what this looks like. Let's say you've got data that you use constantly for 30 days. You keep it in standard S3. That way you don't pay to retrieve it. After 30 days, you almost never use the data, but you occasionally need instant access to it. So you create a policy to automatically, after 30 days, move your data to Amazon S3, meaning IA, meaning the infrequent access. Now it's there. My cool BGP video is viewed 10 times this month, and then chances are nobody's going to want to see it for years. And I'm going to just make a new BGP video, and the next time, here's what we're going to do. We're going to move it to Glacier, and we're going to store it long term. Maybe want to keep a lot of information later to be used for machine learning information for our data science team. Great, we can store it there. Maybe I'm a hospital and I have to keep patient records for 7 years. Maybe I'm a bank that needs to keep my transactions logs for 7 years. We stick it in Glacier. Now in Glacier, we can do something called a vault lock option, which means once it's locked, nobody can touch it. So as you can see, Glacier offers us a lot of options. And lifecycle policies enable us to pay the least amount for our data, have it where we want, when we need it, et cetera, et cetera. Now let's talk about versioning. I love AWS features that bring you back to normal object storage functionality. They love to create curl names for things. With object storage, no matter what, you modify a file by anything else, it creates a new version. Now, if you don't truly understand object storage, and you want to know how bad people don't understand object storage, 16% of all hacking events on the cloud are due to misconfigured S3 buckets. Wow. 16% of all hacks on the cloud are related to people that misconfigured their buckets, their object storage buckets. So it matters that you know what you do. How to configure, that's easy. I can go to the configuration guide and take somebody, and I did it with an 8-year-old. She set up an S3 bucket with 0 time, and she learned in 5 minutes. But what's the complicated piece? Knowing what to use and how to do it and why, not how to configure it. Heck, on my CCIA, the original one, the hard 2-day one, they gave you the configuration guide right there because they knew they would give you a scenario that you had to know so much system design that you could never pass the exam and had a 90% failure rate for that reason. So what versioning is, normally, if you create a version or modify it, it's going to create version. And several of the cloud providers realized that people would set their systems up wrong and get a $10 million bill for the first month, and they'd be kind of aggravated because they didn't know what to use object storage or not. So what they do is they created a feature called versioning, which is the default feature of object storage, that every time you work on a document, it's going to create a new version if you enable this. What would happen if not? They'd have to manually delete them. So what's going to look like? So let's say I was writing a book on passing the certified solution architect, and we use some object storage, and we all use the cloud-based system like Google Drive and Google Word documents or Microsoft 365 on the Azure object storage. I'd create a version. Chris would then say, nope, you misspelled this. Then Chow would look at it from my team. Then Leo would look at it from my team. And each time we'd have a new version. Now over here, version number 153, my cat Cindy ran all over my keyboard and I didn't notice it. And she pushed the save button. And I go back to version number 152 and instead of figuring out what my cat did. That kind of thing, that's what we use versioning. Now, one other cool feature about S3 is multi-factor authentication delete. So multi-factor authentication is two-factor. You're all familiar with it, even if you don't know. Something you have and something you know. Any of you guys want to go to the bank and get some cash, and you take your ATM card and you stick it in the machine, and they ask you for a PIN? Something you have, that card. Something you know, your PIN number. Now, single-factor authentication, I can hack your password relatively easy. Go to Kali Linux and get some tools for your password. Or I can figure out, et cetera, based on lifestyles. I can figure out someone's password. But let's say I compromise your password. If I have multi-factor authentication, it's going to change things. They're going to be more secure. So let's talk about multi-factor authentication with regards to object storage. Here we go. Right now, I realize that I've got on my phone, on my computers, a terabyte of photos of Cindy the cat. And yes, I do. So I've got a terabyte of photos of Cindy the cat. I use some professional cameras, etc., and we take the photos. Now, I realize that I'm going to delete some photos of Cindy the cat. My wife says these 3 photos are unflattering. Get rid of these photos. So I attempt to delete them. Now, normally they would just be deleted. With multi-factor authentication, I intend to delete them. And I get sent a challenge. Hey, by the way, I got a challenge. And I may have on my phone a Google authentication app, an RSA secure ID, a token of some kind. I provide the one-time password, and then the file is deleted. So think about it. You need the password and the multi-factor challenge. And that way, I go to Abigail from my team. Abigail's feeling mischievous today. Abigail decides to play a joke on me and tries to delete a photo of Cindy. Now, when she tries to delete the photo of Cindy, because her cat Noni looks cuter in the photo and the cats are having a competition, I get a text message that says, did you mean to delete this? And I say no. And the photo's still delayed. And then Cindy the cat's all kinds of happy. So that's realistically what we're talking about with regards to this. Let's talk about organizing our data into S3. Now remember, I told you S3 is object storage. It's not traditional storage. So what are we really dealing with? We're dealing with a database structure, realistically speaking, where we got stuff over here and a database pointer pointing to the stuff. So that's realistically speaking what we're kind of dealing with, a database pointer pointing to the stuff. So how does this work? We may create a bucket. And it might be like Mike/2020/AWS videos/storage/s3.mp4. That might be what it looks like over there. Now, the reality is, it's not sitting in that path. That's not a Unix path. I created delimiters to make it look like a Unix path. But remember, cloud storage, object, database pointer to the object. Now let's talk about encrypting your data on S3, etc. We can encrypt it on the client side and the server side. And what is encryption? Okay, so there's a Greek guy on this call. If I say to him, Alexandros, posi systemera isa daxi, Now, that's a basic form of encryption, not very strong. And here's the reason why. Alex knows it, and I know it, and we're talking to each other. Life's good. Oh, wait, there's 10 million Greek people in Australia. There's about 5 million to 10 million Greek people in Greece. There's a couple million Greek people in America. There's Greek people in India, South Africa, Pakistan, etc. So, how good is my encryption? Not that good, because there's probably 20 million people around the world that speak Greek. So, not so good. Now, if I came up with my, and there's other languages like this, there's like patois that was used in the Caribbean, for example, and it was to be a language that other people didn't understand. That was rudimentary levels of encryption, just like my Greek language. Now, encryption enables me to create something where there's a key. And if you don't have the decryption key, it's like a secret decoder ring, you can't understand what the message is. So that's what we're talking about with encryption. Creating something that is completely worthless to somebody if they don't have the key. Now, how long can our key be? In today's world, 256 bits. So pretty long keys. So they're pretty good. And I made a joke about Abigail. Abigail is somebody very special for my team. And the mischievousness with the cat was about the cats being in a little game with us. So don't take that the wrong way. So I'm just trying to have fun with this and trying to bring it to real life for you guys so it doesn't feel so techie and dry. So that's why we're using encryption. Now, what are our encryption options? Now, the encryption options is what we're dealing with. SSE-KMS. And this is basically a customer managed keys with the AWS key management system. And why would we use this? It's a total complete key management system. And the user manages their key. They manage their key. So if I don't want anybody to know the key, including AWS, because I don't trust them, I can use the key management system where I manage my encryption keys. And in high security environments, you're going to have to do this. Now, the key management system will manage the data key. And here's the good news. The key management system will do the following. Provide an audit trail of who, what, when the data was accessed. Great, right? Now, there's a little bit of overhead because the user is going to manage the keys. That is a relatively robust security environment. So let's talk about the next option, SSE-A3, AWS Managed Keys. Again, a complete key management solution. And here, AWS does all the work for you, so it's less secure. They manage all your keys, they rotate your encryption keys, and every object is encrypted with a new encryption key, which is pretty darn awesome. But they have access to your information. Keep that in the back of your mind. Let's talk about SSE-C, and I didn't make up these terms, they did. So here, you have complete and total autonomy over your encryption keys. This is the most secure environment, but it's also the most work. Constant key management, constant changing it back and forth, and you got to owe it all. So there's that. So let's talk a little bit more about S3, and then we'll take a break, and I'll answer some questions on this. Let's talk about some tuning. Give you a few options. The first, I'm going to talk about pre-signed URLs, multiplayer uploads, range gets, and cross-region replication. So all objects in S3 are private. So you need to enable access to reach them. So here's the simplest thing. I have a new thing that I want to send to somebody, Alonzo on my team. Alonzo's made some really cool graphic for me, and he sends it to me, and he doesn't want me to have to figure out enabling access to a bucket and this thing and this thing and this thing. He just wants to make it that I can read it real quick. He can use his own encryption key to sign it and send the message to me. And from there, I can just download it with the link. Why is this cool? He signed it with his own account, and I will have temporary and secure access to it. How long will I have access to the system with this pre-signed key? Well, it's going to be dependent upon the way that he encrypted it. So, for example, if Alonzo sent me this cool new graphic for the company about a new architect course we're working on, for example, or a new certification course, and he signs it with his IAM instance profile, that link is going to be good for 6 hours, max. By comparison, let's talk about this. Let's say in this particular environment, I sign up with the AWS Security Token Service. Wow! It's going to last for 36 hours. Now, I give them a link as an IAM user, and it's good for 7 days. Or a temporary token when it expires. So, you could potentially see these times on an AWS Certified Solution Architect Professional exam. So I might know them, but in reality, as an architect, you're going to look them up every time, because things change. Let's talk about a multi-part upload. I want to send data over a network. The network gets congested. Packets are lost. Not good, huh? No. So the WAN's not good enough. It breaks down. I can send 3/4 of the file, but lost the network connection. Guess what? It's all trash. It's corrupted. So there's nothing we can do. So we can do something called a multi-part upload. And what this really means is you're going to take your big files, you're going to split them down into components. Here, I send you part 1, part 2, part 3, part 4. You got them. I send you part 5, 6, 7, 8, 9, and 10. You got 6, 7, 8, 9, and 10, but lost 5. So guess what? We will talk about that then. So multi-part uploads we're going to use for the following reason. It's going to make our transfers more efficient. So let's look at it. Here we've got a file. We split the file into file part 1, file part 2, file part 3, file part 4, and then the file. And then we store it on AWS. So if the first part gets lost, we just retransmit the first part. And that way we've got reliable performance and less things can go wrong along the way. Last thing is I want to talk about cross-region replication. So imagine you've got users in Lagos, Nigeria, and New York. Now, here's the thing. The wide area connection from New York to Lagos, Nigeria is not the highest performance connection you will see. And guess what? It's an expensive connection. Now, let's say I've got huge data transfers. I've got lots of people in New York, and I've got 1 million people in Lagos, Nigeria trying to pull the information from New York. There's latency. Now, when you're dealing with the cloud providers, they charge you transfer rates per region, and they charge you to use your WAN link. That gets expensive. So what if we need to do this? We take our information, and we replicate the same bucket. So instead of having 1 million users going back and forth, we take the information in New York, replicate it into Lagos, and then we use that for all the people in Nigeria, all the people in Cameroon, etc. They get it locally from that bucket in Lagos, or close to locally. That's what cross-region replication is. So what's this look like? Got your bucket in one region, send it to a bucket in another region. I create a new photo, it sends it over, it replicates it automatically for you. That's cross-region replication. Okay, so let's do this. Let's take some questions, but before we do, I want to remind you, for access to the labs, please register for special access to the labs and register for the free ebook. Covers the associate and professional in the same one, because I want you to have enough knowledge to be good, not just minimum knowledge to pass the certification exam. And tonight, please join us to hear Delroy Batt, who met us a year ago and has now got his first cloud security architect job, and hear how and why he did it and what he learned. It's going to be a fun discussion. Hear this discussion. It may save you years of mistakes to get to your goal. So this is pretty important. While we're at it on Thursday, we're going to have our How to Get Your First Job webinar. And I will tell you what these roles are, what you need to know, the things that need to be on your resume so you can get hired. Because certification is no good if it doesn't end in you getting hired, etc. And there you go. All kinds of cool stuff, including 30% off temporarily to get any of our programs. Lars, if you have a requirement of 5 nines or bigger, do you need to have redundant object storage as well? Absolutely. Past approach? Well, I would put it in a bunch of regions. Now, here's the reality, Lars. If I want redundant storage, I'm not going to put it all on AWS. And here's the reason why. I stuck all my eggs in one basket, AWS. Or I bought a single stock, and I can't imagine why I go bankrupt in my retirement. And here's the reason why. When you've got a cloud, basically the cloud provider is running networks and data centers. Now, it's a private network and data center. If they have a major global outage in one part of the network, it can take down their entire cloud. So redundant storage in a non-redundant environment means a global AWS outage will take you down completely. So I wouldn't do that. Additionally, if a cloud provider has been hacked, and we've had some serious hacking events on these cloud providers, especially Azure, at least Azure was honest enough to tell us about it. Then with, for example, the cloud goes down, it doesn't matter how many availability zones and regions. Again, that's a bad idea. And if the control plane of the cloud's just a network and data center with some software that separates its customers. If that goes down, guess what? You lost the entire cloud. So when you're dealing with high availability solutions, the answer is have your AWS object storage replicate to your Azure cloud storage and replicate that to your Google's cloud storage all at the same time. Because you get a failure in the network and the data center, which is why, Lars, we at Cisco or any company that does deals with high availability systems, Juniper Networks would say the same. What you need to do is if you build a WAN, don't put both of your links on Verizon, and Verizon will tell you not to too. Verizon will say, put this link on me, put this other link on AT&T or NTT or CenturyLink or another service product. Because if we go down, doesn't matter how many links you have from us, you use multiple providers. That's how you deal with it. Good question. Hi, when we back up RDS, does the backup file stored in S3? Yes. Because it's for backup and archival purposes, exactly. Chris, you can go to the next one. What is the difference between standard IA and one zone infrequent? Good question. Standard IA stores your data in at least 2 data centers of availability zones. One zone infrequent means it's only stored in one data center. So if that data center goes down, your data is going to be less available when you need it. Great question. And because your data is less available, they give you reduced prices. Can we alter those 30 days? Yeah, you can make it a day, 30 days, 100 days, 1,000 days. I mean, anything you want it to be. That's why it's based on the business requirements. Architecture, your things that you do are not based upon what's in a piece of paper. They're based upon what the business tells you that they're trying to achieve. That's the start of everything. And great question. Are activities like detected, deleted, logged, and logged? Yes, we can log these things. More than configuration. Looks like someone has to system design and wide cases to cover. So, Praveen, we don't configure as architects. It is of no value to you to know how to configure things other than telling somebody you did. We don't touch the technology. We go to the customer. We ask the customer about their business, which means if we don't have business relevancy and we can't translate a customer's revenue, compound annual growth rate, we can't talk about what's going on macroeconomically, we can't even begin to understand the innovation. Then we must have executive communication skills because we deal with the CEO, the CFO, the CIO, the CTO. Then we must have presentation skills because we're then going to sell. Then we're going to be negotiating a deal. Then, Praveen, the customer is going to say to us, hey, that $1 billion solution you designed is pretty expensive. And we're going to have to say, hey, what we can do is upon analysis of your financial statements, balance sheets, what your customers have told us and what we've seen across industries, this $800 million technology solution will produce an additional $3 billion of revenue while simultaneously doing the following. It will enable you to improve employee productivity by 12%. Then we need to sell that to them, negotiate the deal. We write thought leadership papers. We use our credit card, the company credit card, to buy lunches, dinners, and drinks, et cetera, et cetera, et cetera. So there's kind of those things. And that is our cloud architect career development program. And our students get hired every single day because we teach all of that in our course. Because nobody gets hired because they're certified. Nobody gets hired because they know a name of the service and how to configure it. Nobody gets hired as an architect because they've done Git projects. That's not what we do. None. We design, present, and sell. So what this means is if you're not an expert at designing, presenting, and selling, you can't get hired. So It's all about system design, and that's why we created our Cloud Architect Career Development Program. And here's the reason I do any of this. I interviewed 1,000 AWS certified people before I came out of retirement to produce this program. None of them knew anything about system design. None of them. And when the people can't get hired because I made it clear, now their strategy is here, do a Git project. And you know who doesn't do Git? Architects. So yes, design, present, and sell. And that's our Cloud Architect Career Development Program. Dylan Williams. IAM will be a different day, I assume? Absolutely. Absolutely. IAM is just determining who you are, what you can do, and tracking it. Instant profile is just a person that you're dealing with. So yeah, we'll be dealing with that. Are there any tools? Yeah, it automatically comes with it. But there's lots of ways to do this. It's part of AWS. You guys are talking acronyms. I don't speak acronyms, so I can't help you. We got to communicate in simple and plain language, not acronyms, because I don't know what that means. Can I go over the names of S3 encryption options again? Absolutely. So we have the following options. We have SSE-KMS, and this is a customer management key with the AWS key management system. It's a complete key management system where basically the user manages their master key, and the key management system does the data key. The next option that we have is SSE-S3. This is a complete key management system where AWS manages all the keys and does automatic key rotation, and every object is encrypted with a different encryption key. The next thing is SSE-C, which provides complete autonomy of the encryption key. The customer manages all the keys, most secure, but the highest work. Those are the three types. Great question there, by the way. Excellent question. Cross-region replication, synchronous or asynchronous? I can't remember, but it's pretty close to synchronous, but I think it's asynchronous. Guys, bits with cross-region replication, and you add a Word document to the same data, so will it sync only the changes? It'll sync whatever's changed. Whatever's changed. Good question. Do we store RDS backups? Backups and archivables get stored in block storage. I'm sorry, in object storage. Block storage is more expensive, and that's what you use for your systems, your virtual servers. If you want to put your data in one region data center and put a backup in another region, then do I need to take my permission from a country government authority? Depends on the country. Some countries will make sure that you will mandate that it's in your same country. Yes, absolutely. What's the most secured encryption method you have earlier? Look, the highest security you're going to get on the cloud, and we can do better in the data center, is going to be run an IPsec tunnel on top of a private line. What is the most secure option here? SSE-C, customer managed keys, and here's the reason why. If the cloud provider manages your keys and they get hacked in some way, shape, or form, you're hosed, hacked. So if you manage it yourself and keep your own keys in a safe, and in that safe, you got it in another safe, and you got a bunch of Navy SEALs or Israeli commandos or British SES commandos securing that safe with armed, yeah, that's the most secure way to do it. So, and you could get layered and layered and layered. So when you do it, it's much more secure. Is there an advantage, disadvantage of being a cloud architect who only knows the 3,000 view but doesn't know the nuts and bolts? Okay, I'm going to make this very clear. If your job is to go sell and do a $1 billion solution, and you're focused on the nuts and bolts, you'll be fired in your first week. Fired in your first week, and here's the reason. All of you tonight, go out and take a telescope. Actually, go out tonight and look at the sky. Look at the sun, the moon, the stars. Now, that's what we do. We're the big picture people as cloud architects. No, all of a sudden you want to be smart. You want to get techie. Here's what's going to happen. Now you're going to zoom into the moon to be an engineer and work on it. Now you're working on the moon. You can see the craters on the moon, colors on the moon. What can't you see? The sky. The second you do that, you miss something big and you are fired. Now I'm going to teach you something else. If you need to have MBA level business acumen, and you do, and that's why we include it in our program, and you need to be CXO relevant, and you need to sell, and you need to be highly emotional intelligent, good executive communication skills, good writing skills, entertaining clients, etc. And you're training somebody else's engineering job to be extra techy because you think it's cool. Now, what are you not going to be good at? All the critical skills for your job because you're busy learning somebody else's job. And here's the thing. While you're focused on that, I got somebody that's 25 years old, like Delroy, that's getting hired because he's an excellent cloud architect. And he has the skills that employers desire: leadership skills, communication skills, executive presence, ROI modeling, business acumen. He's getting hired. So yeah, you can spend all your time looking the tech stuff down deep, but you're never going to get hired. And here's the reason. You're going to be going up against on interviews with people with executive communication skills. And here's the other reason. A technical architect is a $100,000 job. A good cloud architect, the enterprise architecture skills, is a $300,000 job. Now, what determines your salary? The scarcity of the resource and the impact you can make on your organization. So who gets paid the most? The most executive people. Here's some statistics for you. Individuals that train emotional intelligence earn 30% more than the average person. Individuals who train emotional intelligence, and that was for soft skills. Individuals who train emotional intelligence on average earn $29.6 thousand more per year. So you could be changing, I'm going to learn the tech. And guess what? You're going to earn $100,000 a year instead of the $150,000, which is the average cloud architect, solution architect salary. Now you focus on your soft skills, your business acumen, your leadership skills, your executive presence, etc., etc. Then you add 30% to that $150,000. That's about $50,000 a year. Then you pick up the emotional intelligence, $30,000 a year, and now you're earning on average $80,000 more a year than the average. So you get techie and you go from 150 to 100 or 110, and you get leadership and you go from 150 to 200 or more. Where do you want to be? It's up to you. What's the difference between S3 sync and cross-region replication and S3 same reason replication? Great question for the cloud engineer on your team. And I would search that every single time on the Amazon website and documentation. I'm not an engineer. I don't do these things each day. I create cloud architects. I have an engineering program which is taught by different people on my team, and they will get into the idiosyncrasies of these things. For them, it's critical. But it's way, way, way beyond the scope of an AWS Certified Solution Architect Professional, let alone an associate. And I can't do that this week because there's so many things. There are so many white papers. What should be the best strategy to cherry pick and target for exam prep? Look, Saurav, if you understand the cloud, meaning the network and data center, it's easy. I spent 2 days to prepare for the Google Professional Cloud Architect exam. Why did I spend 2 days? And I use our AWS book that I wrote with my team to do it, to just prove a point. If you know the cloud, passing any of the exams is nothing. So take this course, read the book, get a practice exam. Review and prep has them relatively inexpensive. I think they're like $20. Practice questions and answers. And when you do these things and you see a question that you don't know, Google it and research everything that you need to know. Then you go to the next question and you don't know what the right answer. Google them. Look at why all of these answers are good. Then go to the next one and Google them. Really master the tech. So that's what I would do. And if you really want to know, go to the web page that AWS has and see which papers really are on the topics on the exam. The book that we wrote will be perfectly fine for the SAACO3. The one that we wrote for the AWS Certified Solution Architect Professional covers the associate and the professional. We put it so much better for 2 reasons. I didn't want everybody needing some training for the associate and different training for the professional. That just would be crazy for me. So I wanted one book that's going to work for everybody. So yes, it's still good. But use the one for the professional, not the associate.
Mike, I think
and it's been recently updated.
Yeah, I think it's important to clarify for everyone that just because the exam structure and the exam questions are being updated doesn't mean that the content is actually being updated. They're just changing it's just a byproduct of the associate certification becoming so, I don't want to say, how should I say this politely? Watered down because everybody gets it. that they have to update it and change it and make it a little bit more difficult because they changed it, so it's not going to be the same that's been around for forever. The content's still the same.
Yeah.
It's just they changed the percentages of this section has this many questions, this section has that many questions. The content's still the same.
Yeah.
So
exactly.
Yeah.
Here's what's going on to make it very clear. You can go to any one of 50 websites, and I get 1,000 people a day. Here's a guaranteed pass for this exam. And what happens is when everybody passes an exam without knowing anything, the exam's value go down. So because the value of the exam go down, they keep trying to change the exam numbers. But it's the same content. They just may ask the questions a little differently to get the cheaters that have memorized the questions and answers from the previous version.
And I also want to remind everybody that tomorrow morning we are doing our cloud career and training question session. So any questions specifically about career, training, development, how to prepare, anything like, can I get a job in this area? Can I get a job in that area? Can I switch from data this to cloud that? We'll definitely take all of those tomorrow. So
absolutely,
that's why I'm sharing that in the chat box. So that'll be at 9 a.m. Eastern time tomorrow. So right now, that's 2 p.m. UK. So afternoon time for most of Europe and Africa. That'll be really early in the morning for the west coast of the U.S. But if you've got any career questions, we'll be taking all of those.
All
tomorrow.
of them. And you can ask me how Daniel Bosu, who didn't even complete high school, got hired as a cloud architect for the world's largest bank. And trust me, he's so smart, capable, good. And I would have hired him for my team should he not had another one. You'll hear from Del Rabat tonight. And you can ask questions about that tomorrow, who's 25 years old. And without us, before us, he had no tech certification. He was an EMT. You can look at our YouTube channel and see people like Coyote. He was in college who got hired by AWS as a solution architect. You can deal with, you can hear about Romanik Eventama, another kind of Marinian, a super good, great guy. The kind of son I wish I had, that kind of really nice, fine young man, gets hired by AWS. His last job was a waiter while I was in college. And the point is, any of you from any background can do it. I come from internal medicine. That's my world. 25 years ago, I switched. And no, I didn't start at the bottom. I wasn't a network admin. I didn't have to do help desk. My first role was a senior engineer. Because if you have the right skills, you can bypass a lot of things. So at tomorrow morning at 9, ask us your career questions. I will dedicate a lot of time to it. And on Thursday, I have a dedicated webinar to help you guys all get to your goals. So, Chris, do we have any more? Or is it time to go back to the content?
It's time for us to go back to the content.
Okay, so we're going to get back to some content. But before we do, if you haven't liked, commented, or subscribed, please do so. We work really hard to produce our content. Please, while you're at it, before today's, at the end of the day, the content's going to be here. Send a tweet, send an email, make a LinkedIn post if you had a good time, and invite other people to attend the free content that we provide. Just the free, that's what we're asking you to promote. So let's get back to some cool technology. Love technology here. So let's talk about instance storage. Okay, so if you want to talk high performance storage, it's instance storage. And what is an instance? I hate this term that the cloud providers have made up. It's just a virtual machine, nothing more than that. So when you deal with the virtual machine, and here's the thing, the cloud is all old tech. It's all old tech. It's all 20 to 40-year-old technology that's been virtualized. And if you don't know the old tech, you can never know how to design it, because what's an architect do? We take the old tech and move it to the cloud, and the same, which is now the new tech, which is the same old tech, it's just been virtualized. So we must understand the old tech. So when we're dealing with instance storage, we're dealing with a virtual machine. What you can actually access inside of this virtual machine is as follows. The hard drives that are there. Now, the local hard drives can be really fast. Why don't we use instance storage? There's one reason. One reason. Upon instance termination, when you delete it, all your data is lost. So that's why we can't use it in the cloud. Rule, I'm going to say it again. I've given you the names of 4 people that never worked in tech before, and you're going to hear from one tonight. Don't let what other people tell you do. Listen to the people that are getting it done. So there's that. So we use block storage because we can't use the instant storage because it goes away with reboot. So it's volatile storage. So what we're going to be using instead is block storage. And AWS calls this high performance block storage. Azure calls it high performance block storage. Google calls it high performance block storage. But when you're dealing with a customer, if you don't understand that block storage is slow, and they do, you'll be escorted out of the room and your replacement will say, thank you for the nice job. So we're going to give you the reality in addition to just the certification. Block storage is this network-based storage. Now, this is high availability storage, meaning 99.99% available. Here's the thing. That means you expect 5 minutes of downtime per year. Not too bad. Now, AWS has to call it elastic block storage because they have to stick the word elastic in front of it. When you talk to your customer, strip the word elastic off, and they know exactly what you're talking about. Now, with block storage, you've got multiple performance options, and they're associated with a single availability zone, and they're backed up to another availability zone or data center. Now, block storage is, realistically speaking, the highest performance we're going to get. And it's going to have multiple performance options, and it's going to be, and Chris, can you hear me or see me? It looks like my YouTube thing froze.
Yeah, I can hear you, but my YouTube thing froze also.
Okay, so
let me go over to Twitch. Twitch is still going. Okay, so it's a YouTube thing. Oh, yeah, we're back.
We're back. Okay, good news. Good news. Okay, so with block storage, we've got multiple performance options, and we're going to talk about what they are, and they're going to be associated with a single availability zone. Now, when we do backups in the cloud, what we're talking about is going to be as following. We're going to be talking about this. We take our virtual machine, which has got block storage attached to it, and we're going to create something called a snapshot, etc., etc. And what is that? That's an image or an exact copy of this, of the hard drive. Now, we can take this snapshot and reconstitute it as a new hard drive anytime you need. So that's what we're talking about. It's an image. Now, when we're dealing with block storage, we have to talk about the performance requirements, the latency, etc. And with block storage, we're going to be dealing with, or with any storage for that matter, we're going to be dealing with latency and throughput. Latency and throughput. What is the difference? Latency is how fast you get access to it, and throughput is how much stuff you can carry. So I like to use the term. I like to compare a Ferrari with a tractor trailer or a big truck. So let's think about this. Latency is how fast you can do something. Like, now we got two cars, the Ferrari and the big slow tractor trailer, and we want to do a quarter of a mile. We take the Ferrari, put an experienced driver in it, and that guy puts the pedal to the metal. He does that quarter of a mile in a couple of seconds. Now we take the tractor trailer, and in the tractor trailer, we got a driver, and he shifts gears, brum, 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 brum. And the quarter mile takes him a minute. So who has lower latency? The Ferrari. Now let's think about who can carry more load. What do I've got in the Ferrari? Whatever I can put in the trunk or the boot, or whatever it's called in your country. What do I put in the tractor trailer? I got a big box that I can fill with stuff. So what you can see is latency is how fast you can do something, and throughput is how much stuff you can carry. Now, what does it matter? If we're dealing with a database that's got 1 million writes per second, I need to read and write to that database 1 million times per second. That's latency. By comparison, if Cindy the cat is sending 4 camera streams, and each camera stream is 800 megabit a second to her friend Noni, I need throughput. I need that tractor trailer, that big pipe. So it's a matter of what your use case actually is. Now, we don't measure latency in terms of latency, but we measure it in terms of the exact opposite, which is the number of times we can input and output or write to the disk and read to the disk per second. So IOPS, or input or output operations per second, is directly inversely related to the latency. The greater the number of input and output operations per second, the less latency you have. Throughput. How many megabits can you push per second through your drive? That's your throughput. So now you know the difference between speed and latency. So how do you determine what you need? you look at your speed and latency of your systems. What does that mean? So we're going to talk about our storage options. And realistically speaking, we're going to start with IO1. IO1 gives you the following. It's provisioned IO pass. This is the second fastest option on the AWS cloud. And it's based upon SSD and NVMe storage written for our environments, and it's designed for a high IO performance. It's great for large databases or applications with lower latency. It gives us a throughput of approximately 1,000 megabit a second. So how does this compare to a drive that you get at Best Buy, a Samsung 980 Pro for $100? An IO1 can go to up to 16,000 IOPS. $150 drive that you stick in your server, in your data center, cost gives you about 1 million IOPS. So what's the speed and performance difference? Well, 1 million is a whole lot more than 16K. So in order to get this to work, we need like 60 of them in a RAID 0 environment. I'll talk about that. So because this is so slow, we might need fast. AWS has come up with a new form called IO2. Now, this is better performance. This will give you 250,000 IOPS. Great, right? And a couple thousand megabit per second for throughput. So, Samsung 980 Pro, 7,000 megabit per second throughput. We're getting a few thousand here. Samsung 980 Pro, 1 million IOPS, and this gets to be up to 250,000 IOPS. So, an IO2 device, which is the blazingly fast performance you get on the cloud, is still a quarter of your $100 drive at Best Buy, but it doesn't cost you $100 a month. I can tell you that right now. And that's going to be used for your biggest databases, et cetera, et cetera, et cetera. So let's talk about the next option, and it's the EBS Viam GP2. This is general purpose SSD storage. Now, because it's SSD, it's going to be relatively low latency, at least with regards to block storage. It's going to give us a good balance of price and performance. And it's going to be decent IOPS, but nothing close to like the IO2 devices or IO1 devices. But here's the problem with this, the throughput. The throughput is 250 megabit a second, which is really slow. So if we don't need to push a lot of data, this is good. 250 megabit per second is basically the speed of a good magnetic drive.
So are we ending it, Mike?
Yeah. I'm just trying to tell people.
Talk with Iman says that you'll pop back up saying, now you know what latency is.
Exactly.
All right. So we got lots of dead air right now. So
okay, lots of dead air. We don't like this.
Can hear us.
So let's do the following. Make sure that you provide enough information. The team provides the links in here. And from there, we'll start back up at noon tomorrow. But I'd like to see everybody here at 6 p.m. tonight.
I'm about to go to downdetector.com for our people on Twitch. Oh, yeah, there's a spike for YouTube. All right. So, yeah, we will see everyone tonight. And I'm about to put all the links in the chat box. And everybody will see those links on Twitch and on YouTube. So I'm going to...
They're actually back. But it doesn't matter.
Yeah, we're back, but it's kind of scary.
Yeah, so ideally, if we're here, we can end it with our users.
Yeah.
And we can speak. I don't see myself on video yet.
Oh, yeah, you're on video. I see you.
On YouTube, you can see me?
Yes. In St. Petersburg, Florida, I can see you.
Okay, so fantastic. Other people are saying refresh your screen. So everyone that can still hear me, because we've had a bunch of people drop off in the last few minutes, what we're going to do is follows.
Because of difficulties with this YouTube, not our end.
Yeah, not on our end. We're still up. Our people can see our internal video across the state. We're actually up on Twitch, but we're going to have our class tonight at 6 p.m. where you can learn all about Delroy and how he got his first tech job without background or experience, and how you can too. And then tomorrow morning, we're going to have our completely free question and answer session. And then tonight, we'll be back. So see you all tomorrow, and give me a cut hard if you can hear me. And we'll see you all tomorrow. We're going to pop in some links in the chat box, and hope you all have a wonderful, wonderful time.